Chapter 11 in 10th standard maths is Introduction to Trigonometry. In some state it could be chapter 5 or chapter 15. So but the syllabus will be same. In the textbook you can see there is an example. One person is watching Qutub Minar at some distance. Okay, let us say he is standing at some distance from Qutub Minar, and this is the distance. Okay, see the cursor, and he is watching the tip of Qutub Minar at some particular angle. If this is the viewing angle, if we know the viewing angle and this distance, we can calculate the height of Qutub Minar. It's not necessary to take a tape and measure. Even if we know the viewing angle, we can calculate what is the height of Qutub Minar. Similarly, in this example you can see one person is watching some object on other side of the bank. If we know the distance between the bank, we can, and if we know the viewing angle, this is the viewing angle. Okay, if we know viewing angle and distance between the bank, we can calculate the height of this tower. Now here in this example you can see one balloon is flying here at point A. If we know the viewing angle and this distance, we can calculate at what height this balloon is flying. Here you can see there is a one right angle triangle is formed. Okay, in the previous example also right angle triangle were formed. Okay, now the balloon, it is flying now at point B. Here also you can see right angle triangle is formed here, and now if this is the viewing angle, at this angle this person is watching this balloon B. So if we know this distance and viewing angle, we can calculate at what height this balloon is flying. So to calculate all these things, we need to know what are trigonometric ratios. So trigonometric ratios are defined with respect to a right angled triangle only. Now see this right angled triangle ABC. Here there is three angles, angle A, angle B and angle C. Angle B is 90 degree. Okay, now with respect to angle A, side BC is called opposite side, because this side is exactly opposite to angle B, that's why it is called opposite side. And this side AB, side AB is called the adjacent side of angle A, and the side opposite to right angle is hypotenuse, as you know it. Now you can see in this figure there is a triangle ABC. I have written the same thing here. Now sine of angle A, there is angle A, angle B and angle C in this right angle triangle, and sine of angle A, or simply I can write sin, sine of A is defined as opposite side by adjacent side, opposite side by hypotenuse side. So with respect to angle A, opposite side is BC, and with respect to angle A, hypotenuse side is AC. So BC by AC gives sine of A. Similarly, cosine of angle A, or simply cos A. Cos A is defined by adjacent side by hypotenuse side, that is adjacent side by hypotenuse side. So adjacent side is AB with respect to angle A, and hypotenuse is AC. Similarly, tangent of angle A, or simply tan A is defined as opposite side by adjacent side. So with respect to angle A, opposite side is BC and adjacent side is AB. Similarly, cotangent of angle A, or cot A. Cot A is defined by adjacent by opposite. So adjacent here is AB, opposite side is BC. Similarly, secant, or in short form SEC. Okay, secant secant of angle A is defined as hypotenuse side by adjacent side. So this is nothing but AC by AB. Similarly, cosecant of angle A is, or simply COSEC I can write, okay, cosecant, in short form COSEC. So cosecant of angle A is defined by hypotenuse side by opposite side. So this is nothing but AC by AB. So here you can make some small observation. Now tangent of angle A, that is tan A. Tan A is defined by opposite by adjacent, that is BC by AB. Okay. Now here in BC by AB, if I divide both numerator and denominator by AC, that is hypotenuse, what will I get? So BC by AC by AB, AB by AC. So BC by AC is nothing but sine of angle A, you can see there, sine A, and AB by AC is nothing but cos A, okay. So tan of A is also equal to sin A by cos A. Now again when you come to cot A is defined by AB by BC, that is adjacent side by opposite side. Now if we divide both numerator and denominator by hypotenuse, that is AB by AC by BC by AC. If we do like this, now AB by AC is nothing but cos A, and BC by AC is nothing but sin A. So cotangent of angle A or cot A is also defined as cos A by sin A. Similarly, you can observe that secant A is given by hypotenuse by adjacent, that is AC by AB, right? So AC by AB is nothing but 1 by cos A. See, cos A is given by AB by AC, therefore AC by AB will be 1 by cos A. Similarly, cosecant of angle A is given by hypotenuse side by opposite side, that is AC by AB. AC by AB is nothing but 1 by sin A. Okay. So these are the basics of trigonometry. It's very important. If you understand this basics, you can solve all the problems. If you don't understand this, you can't go further and do anything. Okay, just understand the basics and then proceed. Now consider one triangle, right angle triangle AMP. So here in this triangle, what is cos A? Sorry, what is okay, cos A is defined as adjacent side by hypotenuse side. Okay, adjacent side by hypotenuse side. So so with respect to angle A, adjacent side is AM and opposite side is MP and hypotenuse side is AP. Okay, so cos A is adjacent side by hypotenuse side, so that is AM by AP. Now if I extend AM further like this, and if I extend AP this way, and if I draw a parallel line which intersects AP extended and AM extended like this, that means this angle is 90 degree. And if I call these two point of intersection as B and C, let this be B, let this be C. Okay, now in triangle ABC, now cos of A is equal to adjacent side by hypotenuse side. So in triangle ABC, adjacent side is AB and opposite side, hypotenuse side is AC. Okay, this I'll mark as 2, this I'll mark as 1, and this is in triangle AMP. Okay, now actually 1 and 2 will be equal, because in triangle AMP in triangle AMP and ABC. Okay, angle A is common in both this triangle, and angle M is equal to angle B, which is equal to 90 degree. Therefore, triangle AMP is similar to triangle ABC. So when two triangles are similar, their sides will be proportional. That means AM by AB will be equal to AP by AC. So AM by AB is nothing but tan of A, and also AP by AC is also equal to tan of A. So what it means? Sorry, this is cos. Okay, cos of A. Cos of A. So so what it means? No matter what the size of triangle, if angle is constant, then the trigonometric ratio will be same only. Similarly, sine of A or tan of A or secant A or cosecant A, all will be same no matter what the size of the triangle. If the angle is constant, if the angle is same, then the trigonometric ratio will not change, it will be the same. This explanation is given in the textbook also. See here, no matter what the size of the triangle, the trigonometric ratio will be same, because we will get similar triangles. Okay, and there are some worked examples here in the textbook. You can go through it. All are self-explanatory. First time you may not understand, but when you go through the problems again and again, when you read it again and again, you will gradually understand everything. You should make a habit of reading textbook also, max textbook. I will be directly going and solving exercise problems. Exercise 11.1, question number 1. In triangle ABC, right angle at B, AB is equal to 24 cm, BC is equal to 8 cm. Determine sin A, cos A, sin C and cos C. So now, before finding that, we should find the length of AC. So according to Pythagoras theorem, AC square is equal to AB square plus BC square. So this is equal to AB is 24 centimeter, 24 square plus BC is 7 centimeter, so 7 square. 24 square is 576 plus for 7 square is 7 7 is 49. So these two gives 9 plus 6 15, carry 1 7 8 9 10 11 12, carry 1 6, so 625. AC square is equal to 625. Therefore AC is equal to plus or minus square root of 625. So we will get plus or minus square root of 625. Square root of 625 is what to find. So I'll take 2 2's are 4. So plus 2 plus 2 is 4. Now here 2 is left, 25. Now 45, 4 5 into 5, 5 5 are 25, 5 4 are 20, 21 22. So this is plus or minus 25. So since AC can't be negative, AC will be plus 25. AC is equal to plus 25 centimeter. 25 centimeter. So now what is sin A? Sin A with respect to angle A, opposite side is BC by AC, so that is 7 by 25. And what is cos A? Cos A is equal to, cos A is adjacent side with respect to angle A, adjacent side is AB and hypotenuse is AC. So this is equal to 24 by 25. Now what is sin C? Sin C. So with respect to angle C, opposite side is AB, and hypotenuse will be same only. Okay, AC. So AB, this is 24 by 25. And what is cos C? Cos C is with respect to angle C. Cos C, adjacent side is BC. BC by AC. So this BC is 7 by 25. Exercise 11.1, question number 2. In figure 8.13, find tan P minus cot R. So figure is not 8.13, it's 11.13. Okay, find tan P minus cot R. So before that we should find QR. So in triangle PQR, applying Pythagoras theorem, we get PR square is equal to PQ square plus QR square. So PR is 13 square is equal to PQ is 12 square plus QR square, we don't know, QR square. So 13 square is 169. When solving this one here, so 12 square is 144. So this is equal to QR square. So this is 169 minus 144 is 25. 25 is equal to QR square, or QR is equal to plus or minus square root of 25. So this is plus or minus 5. So we will take positive value only because QR can't be negative. So QR is equal to 5 centimeter. Okay. Now what is the value of tan P minus cot R, they are asking. So tan P minus cot R is equal to, what is tan P? So this is 5 centimeter. With respect to angle P, tan P is opposite by hypotenuse. Tan P is, so that is QR. Sorry, tan P is opposite by adjacent, that is QR by PQ minus cot R. So with respect to angle R, cot R is adjacent. Cot R is adjacent by adjacent by opposite side, that is QR by QP. So this is equal to QR by PQ. QR is 5. PQ is 12 minus QR is 5. Then QP is 12. So plus 5 by 12 minus 5 by 12, I will get 0. Question number 3. So if sin A is equal to 3 by 4, calculate cos A and tan A. So sin A is 3 by 4. So A, B, C. So sin means opposite by hypotenuse, that is 3, this is 4. Okay. So now what is AB here? Now AC square is equal to AB square plus BC square. So that is 4 square is equal to AB square plus 3 square. So 4 square minus 3 square is equal to AB square, that is 16 minus 9 is equal to AB square. So 16 minus 9 is 7 is equal to AB square, or square root of 7 is equal to AB. So plus or minus, so we will take only positive value, that is root 7. So now what is cos A? Cos of angle A. So cos of A is adjacent by hypotenuse, that is AB by AC. This is equal to root 7 by 4. And what is the tan of A? Tan of A is equal to opposite by hypotenuse, opposite by adjacent. So tan of A is equal to BC by AB. So this is equal to 3 by root 7. Question 4. Given 15 cot A is equal to 8. Find sin A and secant A. So 15 cot A is equal to 8. Therefore, cot A is equal to 8 by 15. So this will be like this. So this is angle A. Cot A is 8 by 15. Cot is adjacent by hypotenuse. Sorry, adjacent by opposite. So this is 8, this is 15. Now what is, if I complete this triangle, this is ABC. Now what is AC? So AC is equal to square root of AB square plus BC square. So this is equal to 8 square plus square root of 8 square plus 15 square. So this is square root of 8 square is 64 plus 15 square. 15 square is 225. So I'll get 289, square root of 289. So find square root of 289. So I'll group like this. 1 ones are 1. So plus 1. 1 plus 1 is 2. So here 2 minus 1 is 1 and 89. Now 27 into 7. 7 sevens are 49. 4 7 2 the 14, 15, 16, 17, 18, 189. So 0 I'll get. So that is AC is 17. So AC is 17. Therefore now sin A. Sin A is given by, sin A is opposite by adjacent, that is 15. 15 by 17. And what is next? There was secant A. Secant A. Secant A is hypotenuse. That is AC, hypotenuse by adjacent side. Okay, that is AB. So this is equal to 17 by 8. Exercise 11.1, question number 5. Given secant theta is 13 by 12. Calculate all the trigonometric ratios. So secant theta, secant means it is hypotenuse by adjacent, that is 13. It is 13 by 12. It's like this. This is theta. Okay, secant theta is 13 by 12. Therefore, what is this one? If I take this ABC, then BC is equal to square root of AC square minus AB square. Okay, therefore square root of 13 square minus 12 square. Square root of 13 square is 13 into 13 169 minus 12 square. 12 into 12 is 144. So this I'll get square root of 25. Okay, so this is equal to 5. BC is equal to 5. I'll get. Now what is sin A? What is the question? Calculate all the trigonometric ratios. Therefore sin A is equal to opposite by adjacent, that is BC by AAC. This is equal to 5 by 13. So sin A or sin theta, okay, whatever they are given in theta, we'll write it in theta only. Now cos theta is adjacent by hypotenuse, that is AB by AC. So this is equal to 12 by 13. So tan A, so tan theta is opposite by adjacent, that is BC by AB. So this is 5 by 12. Cot theta is equal to adjacent by opposite, that is AB by BC. This is equal to 12 by 5. Then secant theta is equal to adjacent by hypotenuse by adjacent. So that is AC by AB. So this is 13 by 12. Oh, this was already given in the question itself. Now cosecant theta is hypotenuse by opposite, that is AC by BC. This is equal to 13 by 5. Question number 6. If angle A and angle B are acute angles such that cos A and cos B, cos A is equal to cos B, then show that angle A is equal to angle B. So given that cos A is equal to cos B and both A and B are acute angles, we should prove that. To prove that angle A is equal to angle B, so the figure is like this. This is A, this is C, this is B. Now what is cos A? Cos A is equal to adjacent by hypotenuse, right? So that is AC, AC by AB, AC by AB. I'll mark this as 1. Now what is cos B? Now cos B is this one. So cos B is given by adjacent by hypotenuse, that is with respect to angle B, adjacent side is BC, BC by AB. Okay, this I'll mark as 2. Now given that cos A is equal to cos B, okay, that means 1 should be equal to 2. 1 and 1 will be equal to 2 only when AC is equal to BC. Okay, 1 equal to 2 only when AC is equal to BC. When AC is equal to BC, what will happen? Angle A will be equal to angle B. Okay, when AC is equal to BC, that means that the given triangle is an isosceles triangle. Therefore angle A will be equal to angle B. 1 is equal to 2 only when AC is equal to BC. Okay, and when AC is equal to BC, angle A is equal to angle B. Okay, when these two sides are equal, these two angles will be equal. See, 1 is equal to 2 means AC by AB, AC by AB is equal to BC by AB. See, in both here denominator are equal, AB. Only when numerator, when they are equal, when numerator also will be equal, then cos A will be equal to cos B. That's why when AC is equal to BC, then 1 and 2 will be equal. That means angle A will be equal to angle B. Exercise 11.1, question number 7. So if cot theta is equal to 7 by 8, evaluate. Okay, given cot theta is 7 by 8, that means if this is theta, cot theta is adjacent by opposite. Okay, so this is A, B, C, let us say. Now what is AC? AC is equal to square root of AB square plus BC square, that is 7 square plus 8 square, applying Pythagoras theorem. Okay, so this is 7 7s are 49 plus 8 8s are 64. So 9, 10, 11, 12, 13, carry 1, 6, 7, 8, 9, 10, 11. So square root of 113. Square root of 113 is AC. Now evaluate 1 plus sin theta. So now what 1 plus, so this is equal to 1 plus, what is sin theta? Sin theta is opposite by hypotenuse. Okay, alright. Sin theta now is 8 by square root of 113. Then cos theta is equal to adjacent by hypotenuse, that is 7 by square root of 113. So 1 plus sin theta is 1 plus 8 by square root of 113 into 1 minus sin theta is 1 minus 8 by square root of 113 divided by 1 plus cos theta. 1 plus cos theta is 7 by square root of 113 into 1 minus 7 by square root of 113. So this is equal to this is in the form of a plus b into a minus b is equal to a square minus b square. Therefore 1 plus 8 by root 3 into 1 minus 8 by root 3 is equal to 1 square minus 8 by square root of 113 the whole square divided by, now in the denominator this is 1 square minus 7 by square root of 113 the whole square. So this is equal to 1 minus square root of 8 is 64 by square root of 113 is square of square root of 113 is just 113 I'll get, okay, like this 113 into 113 is just 113, okay. So divided by 1 minus square of 7 is 60, 7 is 49 by 113. So this is equal to, if we take the LCM, it is 113 by 113 by 64 by 113. So here 113 minus 40 you will get like this. So this is equal to now 113. So 113 minus 64 by 113 minus 49 by 113 I'll get. So 113 minus 64. So these two will get cancelled. So 113 minus 64 is 49 and 113 minus 49 is 64. Next is I should let cot square theta. So cot square theta is nothing but cot theta is already given as 7 by 8. So 7 by 8 the whole square. So 49 by 8 is 64. And that completes this problem. Exercise 11.1, question number 8. So if 3 cot A is equal to 4, check whether 1 minus tan square A by 1 plus tan square A is equal to cos square A minus sin square A or not. So given that 3 cot A is equal to 4, that means cot A is equal to 4 by 3. I'll take that 3 to the right hand side, it will come to the denominator. So cot A is equal to 4 by 3 means it's like this. This is A. 4 by 3 means it will come here. Cot is adjacent by hypotenuse. So this is 4, this is 3. Okay. Now what is AC? AC is equal to square root of 4 square plus 3 square. So that is 16 plus 9. So is equal to square root of 25. I'll get 5. So AC I'll get as 5. So I should check 1 minus tan square A by 1 plus tan square A. What is the value of this one? So 1 minus tan is opposite by hypotenuse, that is 3 by opposite by adjacent. So 3 by 4 the whole square minus 1 plus now tan square 3 by 4 the whole square. What is the value of this one? So this is 1 minus 3 3s are 9 by 4 4s are 16 divided by 1 plus 9 by 16. So I'll get 16 is the LCM. So 16 minus 9 here. I'll get here 16 plus 9 by 16. So 16 will get cancelled. So 16 minus 9 is 7 by here. 16 plus 9 is 25 I'll get. So I'll mark this as 1. Now I'll check what is cos square a minus sin square a. Cos square a minus sin square a is, so cos square a is adjacent by hypotenuse, that is 4 by 5 the whole square. AC I got as 5, minus sin square is opposite by hypotenuse 5 by 3 the whole square. So this is equal to 16 by 25 minus 3 is 9 minus 25. So here I am getting 7 by 25. So this I'll mark as 2. So 1 is equal to 2. It's proved. That means 1 minus tan square a by 1 plus tan square a is equal to cos square a minus sin square a. Exercise 11.1, question number 9. In triangle ABC, right angle at B, if tan A is 1 by root 3, find the value of sin A cos C plus cos A sin C. And the second one is cos A into cos C minus sin A into sin C. So given tan A is equal to 1 by root 3, that means if I take this as angle A, so tan A is opposite by adjacent, that is 1 and this is root 3. And given that it's right angle at B, okay, so ABC. So now what is AC? AC is equal to, applying Pythagoras theorem, AC is square root of AB square plus BC square. So this is equal to square root of root 3 the whole square plus 1 square. So this I'll get square root of 3 the whole square is 3 only plus 1. So this is square root of 4. I'll get 2. So AC is 2. Now I should evaluate. What should I evaluate? First one, evaluate sin A cos C plus cos A into sin C. So now sin A, what is sin A? Sin A is opposite by hypotenuse, that is 1 by 2 into now cos C. Now with respect to angle C, cos C is adjacent. With respect to angle C, adjacent side is CB, that is 1. Hypotenuse is 2. So plus now cos A is root 3 by 2 into sin C. So sin C is with respect to angle C. Sin C is opposite by hypotenuse, that is root 3 by 2. So this I'll get so 1 by 2 into 1 by 2, multiply the numerator, that 1 into 1 is 1, 2 into 2 is 4, plus, so here root 3 into root 3 into root 3 is 3, okay, 3, 2 into 2 is 4. So now LCM is 4, 1 plus 3, I'll get 4 by 4 is equal to 1. Now second one, what is the second thing I should evaluate? Cos A into cos C minus sin A into sin C. So cos A with respect to angle A, cos A is root 3 by 2, that is adjacent by hypotenuse. Then cos C with respect to angle C, cos C is adjacent by hypotenuse, that is 1 by 2, minus sin A with respect to angle A, adjacent side opposite side is CB, that is 1 by 2, and sin C with respect to angle C, sin C is opposite by hypotenuse, that is root 3 by 2. So I'll get root 3 by 1 into root 3 is root 3 only, 2 into 2 is 4, minus here 1 into root 3 is root 3 by 2 into 2 is 4. So plus root 3 by 4 minus root 3 by 4 is 0. This is 1, okay. Exercise 11.1, question number 10. In triangle PQR, right angle at Q, PR plus QR is equal to 25 centimeter and PQ is equal to 5 centimeter. Determine the values of sin P, cos P and tan P. So the figure is like this: PQR, and PQ is 5 centimeter. Okay, this is 5 centimeter, and given that PR plus QR is equal to 25. Now I'll mark this as equation 1. Now I'll apply Pythagoras theorem. So according to Pythagoras theorem, PR square is equal to PQ square plus QR square. Okay. Now PR square is equal to PQ is given as 5. So 5 square plus QR square. Now what is QR? See, from 1 I'll get QR is equal to 25 minus PR. I'll solve for PR. Okay. If I bring this to the right hand side, QR is 25 minus PR. I'll substitute that same thing here. Now PR square is equal to 5 square is 25 plus QR I got as 25 minus PR, so the whole square. So from 1, equation 1. Now PR square is equal to 25 plus, now here I'll expand this one, 25 square minus PR square minus 2 into 25 into PR. So I'll use the formula A minus B the whole square. A minus B the whole square is A square plus B square minus 2AB. Using this I'll expand 25 minus PR the whole square. So I'll get this much. So here PR square will get cancelled. So 0 is equal to 25 plus 25 square minus 2 into 25 into PR I'll get. So now I'll divide by 25. Divide this equation by 25. So 0 by 25 is equal to 25 plus 25 square minus 2 into 25 into PR I'll get by 25. So 0 by anything is 0 only. So this is equal to, now I'll expand this one, I'll split this one. So 25 by 25 plus 25 square by 25 minus 2 into 25 into PR by 25 I will get. So here 25 will get cancelled. This 25, this square symbol will get cancelled. So 25 will get cancelled here. So 0 is equal to 1 plus 25 minus 2 PR I'll get. So 26. So 1 plus 25 is 26. 0 is equal to 26 minus 2 PR. Or if I take PR to the left hand side, 2 PR is equal to 26. Or PR is equal to, now 26 by 2 is equal to 13. So if I'll substitute PR, PR is equal to 13 in 1, what will I get? So 1 is PR plus QR is equal to 25, right? So PR is equal to 13 plus QR is equal to 25. Now QR is equal to 25 minus 13 is equal to 12. So QR I will get 12. So I am writing in the diagram, you can check it. QR is 12 and PR how much I got? 13. Now what is sine of P? Sine of P is opposite by adjacent, that is 12 by 13. Now what is cos of P? Cos of P is adjacent by hypotenuse, that is 5 by 13. Now what is tan of p? Tan of p is opposite by adjacent, that is 12 by 5. Exercise 11.1, question number 11. So state whether the following are true or false. Justify your answer. First up question, the value of tan A is always less than 1. Tan A, now consider this triangle ABC. Now tan A is given by BC by AB. So when tan A will be equal to 1, when BC is equal to AB, only then it will be tan A will be equal to 1. If BC is greater than AB, value of tan A will be greater than 1. So it is false. Tan A can be greater than 1 also. If opposite side is greater than adjacent side, then tan A will be greater than 1. Second sub question, secant A is 12 by 5 for some value of angle A. So this is true. So secant A, ABC, secant A is hypotenuse by adjacent side. So for some value of A it can be so this is true. And third one, cos A is the abbreviation used for cosecant of angle A. No, it's false. Cos A means cosine of A. Okay, it's cosine of angle A, not cosecant of angle A. Then fourth, cot A is the product of cot and A. False. This is false. See, cot A, B, C. Cot A is adjacent by hypotenuse, that is cot A is equal to AB by AC. So it's not the product of cot and A. Just cot means it is meaningless. A is angle, okay, but cot A is not the product of cot and angle A. Okay, false. Cot A is adjacent by hypotenuse. Now fifth one, sin theta. Sin theta is 4 by 3 for some angle theta. Yes, true. See, for some angle, say this is theta. For some angle theta, what is sine of theta is opposite by adjacent. 4 by, so this 4 3. It can be for some angle theta, opposite could be 4 and adjacent could be 3. Oh sorry, this is false. Because always hypotenuse is always greater than opposite side and adjacent side. Okay, it can be sin theta can be 3 by 4. It can never be 4 by 3. Always hypotenuse is greater than opposite side and adjacent side. Therefore sin theta is equal to 4 by 3 is false. So I'll write one sentence. Hypotenuse is greater than opposite side. So that's why in sin theta always the numerator should be lesser than the denominator. So sin theta is 3 by 4 is okay, but it can never be 4 by 3. Numerator cannot be greater than the denominator. The next topic in this chapter is trigonometric ratios of some specific angles, and the first one is trigonometric ratios of 45 degree. Now consider one right angle triangle ABC. Let angle B is equal to 90 degree and angle A is equal to 45 degree. See, when angle A is equal to 45 degree, angle C also will be 45 degree, and AB, side AB will be equal to side BC. Okay, suppose if side AB is 1 and BC is 1, what will be this side AC? AC is equal to square root of AB square plus BC square. Therefore it is 1 square plus 1 square is equal to 2. Square root of 2 I will get. AC is equal to square root of 2. Now what is with respect to angle A, sin 45, what is sin 45? Opposite by hypotenuse. So sin 45 is 1 by root 2 I will get. And similarly cos of 45. Cos of 45 is adjacent by hypotenuse. Cos 45 also I will get 1 by root 2. And what is tan 45? Opposite by adjacent, that is 1 by 1 I will get 1 only. And what is cot of 45? Adjacent by hypotenuse, that is I will get 1 by 1 is equal to 1. And what is secant 45? Secant 45 is hypotenuse by adjacent, that is root 2. Root 2 by 1 I will get as root 2 only. And what is cosecant 45? Hypotenuse by opposite. So this also I will get square root of 2 by 1 is equal to root 2. The next is trigonometric ratios of 30 degree and 60 degree. For this one I will take one triangle ABC. This is an equilateral triangle. Equilateral triangle means all angles will be equal to 60 degree, right? Okay. And let the sides be 2 units each. Okay, let AB be 2 units and AC be 2 units and BC be 2 units. And if I draw one altitude from A to BC, and I will call this point as D. So altitude always bisects the base. That means BD is, now BC is 2 units, therefore BD will be 1 unit and DC will be equal to 1 unit. Okay, now angle A is divided into 2 parts. Okay, you can see this is 30 degree and this is equal to 30 degree. Now you can see, now in triangle A, in triangle ABD, now what is sin 30 degree, sorry, sin 60 degree, sin 60 degree. Now before going here, now what is the length of AD? Now AD is equal to square root of AB square minus BD square, right? So this is equal to 2 square minus 1 square. So 4 minus 1. So this is equal to square root of 3. So AD I will get as square root of 3. So this I got according to Pythagoras theorem. Altitude AD will be equal to root 3. Now coming to this triangle ADB, angle B is 60 degree. Therefore what is sin 60? Sin 60 is opposite by hypotenuse. That means AD by AB I will get as root 3 by 2. Similarly cos of 60 degree. Cos of 60 is adjacent by hypotenuse, that is BD by AB. So that is 1 by 2 I will get. And tan of 60 degree. Tan of 60 degree is, I'm talking all with respect to angle B here. Okay. Now tan of 60 degree is opposite by adjacent, that is root 3 by 1 which is equal to root 3 only. And what is cot of 60 degree? Cot of 60 is adjacent by opposite, that is 1 by root 3 I will get. BD by AD. Now what is secant? Secant of 60 degrees. Secant of 60 degrees, hypotenuse by adjacent, that is 2 by 1. 2 by 1 is 2. And what is cosecant? Cosecant 60 degree. Cosecant 60 degree is hypotenuse by opposite, that is AB by AD, that is 2 by root 3. Okay, similarly, now what is sin 60? Sorry, sin 30 degree. Now consider the same triangle ABD. Now angle A is divided into two parts, okay, two equal parts, that is 30 degree and 30 degree. Now with respect to angle A, sin 30 degree will be equal to opposite by hypotenuse. So sin 30 is 1 by 2. Now cos of 30 degree. Cos of 30 degree is, so all this is in triangle ABD only, ABD. Okay, now cos of 30 degree. Cos of 30 degree is adjacent by hypotenuse, that is root 3 by 2 I will get. And tan of 30 degree. Tan of 30 degree is opposite by adjacent, that is 1 by root 3 I will get. And cot of 30 degree. Cot of 30 degree is adjacent by opposite, that is root 3 by 1. And secant of 30 degree. Secant of 30 degrees adjacent by hypotenuse by adjacent side, that is AB by AD, that is 2 by root 3. Now cosecant of 30 degree is equal to hypotenuse by opposite, that is 2 by 1 I will get. So in all these cases, when it comes to 30 degree, okay, the trigonometric ratios of 30 degree, you should consider this triangle, that is ABD. This is 60, angle D is 90, angle A is 30 degree. Okay, like this you should consider. So this is 2, this is root 3, and this is 1. Like this if you consider, you will get sin 30, cos 30, tan 30, cot 30, secant 30 and cosecant 30. Now we will see what are the trigonometric ratios of 0 degree and 90 degree. Now consider triangle ABC, in which angle B is very small. Very small means so small that it is almost equal to 0 degree. Consider such a triangle, and angle C is 90 degree. Now if BC is 1 unit, AB also will be equal to 1 unit. When B is very small, then BC is also equal to AB. BC is almost equal to AB. BC is almost equal to AB, and length of AC will be almost equal to 0. Okay, this will be 0 units. BC will be 1 unit and AB also will be 1 unit, but BC becomes almost 0 units. Okay, now what is sin of 0 degree? Now sin of 0 degree is opposite by hypotenuse, that is AC by AB. Now AC is almost 0, it's 0 only. Okay, so 0 and AB is 1, so 0 by 1 is 0 only. Now similarly cos of 0 degree. Cos of 0 degree is adjacent by hypotenuse, that is BC by AB. So this is BC. When angle B is almost equal to 0, BC will be equal to AB, that is 1 by 1. Both will be equal. So this is 1. So now tan of 0 degree. Tan of 0 degree is opposite by adjacent, that is AC by BC. This is equal to 0 by 1. I will get 0 only. Now cot of 0 degree. Cot of 0 degree is adjacent by opposite, that is BC by AC. So this is equal to 1 by, so AC will be very small, so 1 by 0 I'll get. So 1 by 0, actually this is not defined in max. Okay, this is called as infinity, this value is infinity, and it is not defined. Okay, in your textbook it's given not defined. I'll write as not defined only. 1 by 0 is not defined. Now secant of 0 degree is, secant is hypotenuse, that is AB by adjacent, hypotenuse by adjacent, AB by BC. So the AB by BC is AB is 1 and BC is equal to 1. So 1 by 1 is 1 I'll get. Now cosecant 0 degree is AB, hypotenuse AB by opposite, hypotenuse by opposite, that is AB by AC. So here it is, AB is 1 and AC is 0. So this is also not defined. Now let us compute what are the values of, what are the trigonometric ratios of 90 degree. Now consider one triangle, okay, ABC. So angle C is 90 degree, and let angle B so large that it is almost equal to 90 degree. Now like this, okay, it's something like 89 point something like that. Okay, we can approximate to 90. Approximate angle B is 90 degree. Now what is sine of 90 degree? Now one more assumption will make. When B is almost equal to 90 degree, BC will be almost equal to 0 units. It becomes 0. It becomes so small that it's we can equate it to 0. And when angle B is when angle B is 90 degree, almost AC will be equal to AB. So let us assume that AC is 1 units. So when angle B is 90 degree, AC also will be equal to 1 units. Okay. So now what is sine 90 degree? Sine 90 degree is opposite by hypotenuse, that is 1 by 1 will get 1. Sine 90 is 1. So now cos of 90 is adjacent by hypotenuse, that is BC by AB. So this is equal to 0 by 1, which is equal to 0. Now what is tan of 90 degree? Tan of 90 degree is opposite by adjacent, that is 1, that is AC by BC. AC is 1 and BC is 0. So 1 by 0 is not defined. Now cot of 90 degree. Cot of 90 degrees adjacent by hypotenuse, sorry, opposite. So BC by AC. So BC by AC, BC is 0, AC is 1. So 0 by 1 is 0. Now similarly, what is secant of 90 degree? Secant of 90 degree, hypotenuse by adjacent, that is BC. So AB is 1 and BC is 0. So this is also not defined. And what is cosecant? Cosecant of 90 degree is hypotenuse by opposite, that is AC. So this is equal to 1 by 1. 1 by 1 is equal to 1. Now you can see that I have made a table of trigonometric ratios. Just now we computed the values of trigonometric ratios of 0 degree and 90 degree. So for 0 degree we got these values, right? So I'll put those values here. Now sine of 0 is I got 0, and cos of 0 I got as 1, and tan of 0 I got as 0, and cot of 0 degree is not defined. Okay, and secant of 0 degree is 1, and cosecant of 0 degree is not defined. Okay, similarly for trigonometric ratio of 90 degree also we derived just now. So for 90 degree sin A is 1. Okay, that is these values. Okay, now sin of 90 degrees 1 we got, cos of 90 we got 0, tan of 90 we got not defined, and cot of 90 degree we got 0, secant of 90 degree we got not defined, and cosecant of 90 degree we got as 1. Okay, the last column is not there, and in the previous page we already computed the values of trigonometric ratios of 45 degree and 30 degree and 60 degree. Okay, that also will put it in this table. Okay, so sin 30 degree I got as 1 by 2, cos of 30 degree I got root 3 by 2, and tan of 30 degree I got 1 by root 3. Then cot of 30 degree I got 1 second, yeah, cot of 30 degree I got as root 3, and secant of 30 degree I got 2 by root 3, and cosecant of 30 degree I got as 2, and sine of 45 degree I got as 1 by root 2, and cosecant 45 degree I got as that also I got as 1 by root 2. Then tan of 45 degree I got as 1. Then cot of 45 degree also I got as 1. Then secant of 45 degree I got as root 2. Then cosecant of 45 degree also I got as root 2. Now cot of sine of 60 degree I got as root 3 by 2, and cosecant of 60 degree I got as 1 by 2, and tan of 60 degree I got as root 3, and cot of 60 degree I got as 1 by root 3. Then secant of 60 degree I got as 2, and cosecant of 60 degree I got as 2 by root 3. Now there are so many values, it's very hard to remember all these values, and now I'll tell you one easy way how to remember all these values. There is one easy method to remember all the trigonometric ratios. You make one row which contains this way, put 0 degree, 30 degree, 45 degree, 60 degree and 90 degree, and in one column you put sin A, cos A, tan A, cot A, secant A and cosecant A, and in the second row you write 0, 1, 2, 3 and 4. Now you divide all by 4, that is 0 by 4, 1 by 4, 2 by 4, 3 by 4 and 4 by 4. Now you take the square root of all. When you take it, now 0 by 4 is 0 only, square root of 0 is 0 only. Now 1 by 4, square root of 1 by 4 is 1 by 2. Square root of 1 is 1, square root of 4 is 2. So this turns out to be 2. So that means sine of 0 is 0, sine of 30 is 1 by 2, sine of 30 is 1 by 2. Now sine of 45, so this is 2 under 2, 2 to the 4, I'll get as 1 by root 2. So sine of 45 is 1 by root 2. Now sine of 60 degree is nothing but root 3. Square root of 4 is 2. Root 3 by 2 is the value of sine 60 degree. And 4 by 4 is 1 by 1. That is 1. Square root of 1 is 1 only. So that means sine of 90 degree is 1. And now to compute cos of A, what we'll do is, now come in the reverse direction. See, now you went this way you went. Now come in the opposite direction. So you know, just write down the values in the reverse order. That's it. For sine 0 you got as 0. That one put it at the end. Now here sine of 30 you got as 1 by 2. That 1 by 2 you put it here. Now cos sine of 45 degree you got as 1 by root 2. That one you put here like this. Now sine of 60 degree I got as root 3 by 2. So put that one here, root 3 by 2. Sine of 90 I got as 1. So these are the values of cos A. That is, cos 0 degree is 1. Cos of 30 degree is root 3 by 2. Cos of 45 degree is 1 by root 2. And cos of 60 degree is 1 by 2. And cos of 90 degree is 0. Now what is tan? So tan A is nothing but sin A by cos A, right? Sin A by cos A. So now just divide sin A by cos A, you will get the value of tan A. So sin of 0 is 0, cos of 0 is 1. So 0 by 1 I will get as 0 only. And now here tan of 30 degree, 1 by 2 divided by root 3 by 2. So 1 by 2 divided by root 3 by 2, I will get as 1 by 2 into 2 by root 3. So 2 will get cancelled, 1 by root 3 I will get. So tan of 30 degrees 1 by root 3. Okay, tan of 30 degree. Now tan of 45 degree, now divide sin 45 divided by sin cos 45, that is 1 by 2 divided by 1 by 2 I will get as 1 only. Now here tan of 60 root 3 by 2 divided by 1 by 2. Okay, now tan of 60 is sin of 60 divided by cos of 60, I will get as root 3 by 2 by 1 by 2. So this is equal to root 3 by 2 into 2 by 1 I will get. So 2 will get cancelled, I will get root 3. Now tan of 90 degree. So here 1 divided by 0, 1 divided by 0 I will get not defined. This is not defined. Okay. Now whatever values you got tan, you put it in the reverse order. That is, my cot 90 degree will be tan of 0. That is like this. You put it in the 0 order. Tan 0 is put it in reverse order. Tan 0 is 0. So that will be cot 90. Now tan 30 degrees 1 by root 3. So here that will come in this place, that is 1 by root 3. I am just putting tan values in the reverse order, that's it. So here it is 1, here it is root 3, and this is not defined I will get. Now what is secant of 0? Secant of 0, what is secant? Secant is defined by 1 by cos, right? So secant of 0 is equal to 1 by cos 0. So cos 0 is 1. So 1 by 1 is 1 only. So secant of A is 1 I will get. Secant of 0 is 1. So just take inverse of cos A, you will get secant A. So secant of 30 is 1 divided by root 3 by 2. I will get 2 by root 3. Okay. Secant 30 is equal to 1 by cos 30. So 1 divided by cos 30 is root 3 by 2. So this is equal to 2 by root 3 I will get. just take inverse of cos, you will get values of secant. Now cos secant of 30 is 1 by root 2 is root 2. Now secant of 60 degrees 1 by 2, that is 2 I will get. And secant of 90 is 1 by cos of 90. So 1 by 0, 1 by 0 is not defined I will get here. Now cosecant of A is 1 by sine of A, that is 1 by 0, 1 by 0 I will get not defined. And here cosecant 30 is 1 by sine of 30, 1 by 2, sine 30 is 1 by 2, 1 by 2 is 2. Okay, see, cosecant 30 is equal to 1 by sine of 30, so 1 by 2 is 2. So here now cosecant of 45 is 1 by sine 45, that is 1 by root 2 is root 2. Now cosecant of 60 is 1 by root 3 by 2, so I will get 2 by root 3. And here cos of 90 is 1 by sin 90, so 1 by 1 is 1 only. So in this is a easy method to write all the trigonometric ratios. Even if you don't remember, it's okay, you can just within 1 or 2 minutes you can make this chart and you can use it to solve your problems. So whatever given in the textbook, same thing I have explained. I have made it as simple as possible. So whichever explanation you feel is easier, my explanation or the textbook explanation, you can go for it. There are some worked examples, you can just go through it. I won't be explaining all these worked examples, it's all self-explanatory. I'll be directly solving exercise problems. Exercise 11.2, first question, evaluate the following. First sub question, sin 60 into cos 30 plus sin 30 into cos 60. So sin 60, what is the value of sin 60? Sin 60 is root 3 by 2. Cos of 30 is root 3 by 2 plus sin of 30 is 1 by 2 and cos of 60 is also 1 by 2. So this is equal to root 3 into root 3 is 3 only, 2 into 2 is 4 plus 1 into 1 is 1, 2 into 2 is 4. So this is equal to LCM is 4, 3 plus 1 4, 4 by 4 I'll get 1. So second sub question is 2 tan square 45 degree plus cos square 30 degree minus sin square 60 degree. So this is equal to, now what is the value of tan 45? Tan 45 is 1, so 2 into 1 square plus cos square 30, cos 30 is root 3 by 2 the whole square minus sin square 60, sin 60 is root 3 by 2, so this square. Then now 2 into 1 square is 1 plus root 3 by 2 is 3 by 4, so root 3 into root 3 I'll get 3 only, and 2 into 2 is 4 minus, so here also I'll get 3 by 4 I'll get. So this plus 3 by 4 minus 3 by 4 will get cancelled, 2 ones are 2 is the answer. So third sub question, cos 45 degree divided by secant 30 degree plus cosecant 30 degree. So now what are the values? Now substitute. So cos 45 degree, cos 45 is 1 by root 2. Okay, so 1 by root 2, 1 by root 2 divided by secant of 30 degree. Secant of 30 degree is 2 by root 3, 2 by root 3, plus cosecant of 30 degree. Cosecant of 30 degree is 2. So this is equal to 1 by root 2 by, now here root 3 I can take as LCM, root 3. So this 2 plus 2 root 3 I'll get. So now this is equal to 1 by root 2. So into, I'll take the denominator to the numerator. So in the numerator it becomes root 2 by 2 plus 2 root 3. So root 2 will get cancelled. I'll be left with 1 by 2 plus 2 root 3. Oh sorry, I have made one mistake here. This is root 3. So this will become 1 by root 2, 1 by root 2 into, now denominator I'll take to the numerator, it becomes root 3 into root 3 by 2 plus 2 root 3. Okay, now here there are two irrational numbers, this and this. So if I rationalize it, first I'll rationalize the first part. So I'll multiply and divide by root 2. So when I multiply and divide by root 2, I'll get as root 2 by root 2 into 1 by root 2 into root 3 by 2 plus 2 root 3. Okay, now here root 2 in the denominator, root 2 into root 2 I'll get root 2 only. So in the numerator I'll get root of 2 into 3. In the denominator, root 2 into root 2 is just root 2 into 2 plus 2 root 3 I'll get. Now I'll get root 6 by 2 into 2 plus 2 root 3. Now even this is also a rational number, this part. So I need to rationalize this one. So what I'll do is I'll multiply and divide by 2 minus 2 root 3. So root 6 by 2 into 2 plus 2 root 3 into 2 minus 2 root 3 by 2 minus 2 root 3 I'll do. So now I'll get root 6 into 2 minus 2 root 3 divided by, see in the denominator this is of the form of a plus b into a minus b. Okay, so a plus b into a minus b is equal to a square minus b square. So in the denominator I'll get 2 square minus 2 root 3 the whole square I'll get. Okay, now this is equal to root 6 into 2 minus 2 root 3 divided by 2 into, so 4 minus, now 2 root 3 the whole square is 2 2s are 4, root 3 the whole square is 3 only. So 4 into root 3 I'll get there. So this is equal to root 6 into 2 minus 2 root 3 by 2 into 4 minus 4 3 is 12. So 4 minus 12 is minus 8. Okay, so root 6 into 2 minus 2 root 3 by minus 16 I'll get. So now what I'll do is in the numerator I'll take 2 common factor, 2 into 1 minus root 3. I'll write this way. Now minus 16. Now 2 1s are 2, 2 8s are 16. So I'll get root 6 into 1 minus root 3 by minus 8. So now again, so root 6 So into, so here I'll take minus 1 as common factor. If I take minus 1 as common factor, I'll get root 3 minus 1, okay, by minus 8. Now minus minus will get cancelled, so I'll get root 6 minus in the numerator and minus in the denominator will get cancelled. Or one more step, I'll write root 6 into minus 1 into root 3 minus 1 by minus 8. So this minus will get cancelled. So I'll get root 6 into root 3 minus 1 by 8. Again here, if I open the bracket, root 3 root of 6 into root 3 into root 6 into root 3 minus root 6 by 8 I'll get. So this again I'll get root of 6 3s are 18, 6 into 3, okay, one more step I'll take, minus root 6 by 8. So this is equal to root of 6 3s are 18 minus root 6 by 8. So root 18, if I factorize it, 2 9s are 18, 3 3s are 9, 3 1s are 3. So root 18 I can write as 2 into 3 minus root 6 by 8. So here I can take this 3 outside. 3 root 2 minus root 6 by 8 is the answer. The next sub question is fourth. So sin 30 degree plus tan 45 degree minus cos 60 degree by secant 30 degree plus cos 60 degree plus cot 45 degree. So sin 30 degree is 1 by 2, tan 45 degree is 1 minus cosecant 60 degree. Cosecant 60 degree is 2 by root 3, okay, divided by secant 30 degrees 2 by root 3 plus cosecant 60 degree. Cosecant 60 degrees 1 by 2, so plus 1. So this is equal to, now 1 by 2 plus 1. So 1 by 2 plus 1 is 3 by 2. 3 by 2 minus 2 by 3 divided by 2 by root 3. So here also 1 by 2 plus 3, 1 by 2 plus 1 is 3 by 2. So 1 by 2 plus 1, if I take LCM is 2. So 1 plus 2 I'll get, so 3 by 2. So 1 by 2 plus 1 is 3 by 2. So now this is equal to, now again I'll take LCM. LCM of 2 and 3, LCM of 2 and 3 is 2 root 3. So 3 into root 3 minus 2 into 2 I'll get in the numerator, and here again in the denominator also LCM of root 3 and 2 is 2 root 3 is the LCM. So I'll get 2 into 2 plus 3 into root 3 I'll get. So this and this will get cancelled. I'll be left with 3 root 3 minus 4 divided by 4 plus 3 root 3. Now denominator is irrational number. I should rationalize it. So to rationalize it, I will multiply and divide by 4 minus 3 root 3. 4 minus 3 root 3. So this is a rational number. Now if I multiply like this, the denominator will become, sorry, this is a irrational number. When I multiply both numerator and denominator by 4 minus 3 root 3, the denominator will become a rational number. So now it is 3 root 3 minus 4 into 4 minus 3 root 3. So here in the denominator it is in the form of a plus b into a minus b is equal to a square minus b square. Therefore it is 4 square minus 3 root 3 the whole square. In the numerator I'll take 1 as minus 1 as common factor in the first term. So it is now it is 4 minus 3 root 3 into 4 minus 3 root 3. Only in the first term I have taken minus 1 as common factor. Now in the denominator it is 16 square, sorry, 4 4s are 16, 16 minus 3 3s are 9 into root 3 into root 3, root 3 into root 3 is 3. So here now I will get minus 1. So here 4 minus 3 root 3 into 4 minus 3 root 3 is a minus b into a minus b is a minus b the whole square. So a minus b the whole square is a square plus b square minus 2ab. So I'll expand it. So that is 4 square plus 3 root 3 the whole square minus 2 into 4 into 3 root 3. Okay. Now divided by 16 minus 9 3 is 27. So now I will get minus 1 into 16 plus 3 3 is 9 into root 3 into root 3 is 3 minus 2 4s are 8 8 3 is 24 root 3 divided by, now 16 minus 27 is minus 11. So this minus will get cancelled. So I am left with 16 plus 27, 9 3s are 27. So 16 plus 27, 16 plus 27 I will get 43. So 43 minus 24 root 3 divided by 11 is the answer. And that completes this problem. Exercise 11.2, question number 1, sub question 5. 5 cos square 60 plus 4 secant square 30 minus tan square 45 by sin square 30 plus cos square 30. Evaluate this one. So now this is equal to 5. Now substitute the values of cos 60. Cos 60 is 1 by 2. So 5 into 1 by 2 the whole square plus 4 into secant 30 is 2 by root 3. 2 by 3 root 3 the whole square minus tan 45 is 1. So 1 square by sin 30 is 1 by 2 the whole square plus cos 30 is root 3 by 2 the whole square. So this is equal to 5 into 1 by 4 plus 4. So this is 2 by root 3 the whole square is 2 into 2 4. Then root 3 into root 3 is 3 minus 1. So now here 1 by 2 the whole square is 1 by 4 plus root 3 by 2 the whole square. Root 3 the square is root 3 into root 3 is 3. So denominator 2 into 2 is 4. So this is equal to 5 by 4 plus 4 4s are 16 by 3 minus 1 divided by, so here 4 is the LCM, so 1 plus 3. So this is equal to 5 by 4 plus 16 by 3 minus 1 divided by, here 4 by 4. So 4 by 4 is 1. So I will be left with 5 by 4 plus 16 by 3 minus 1. Now take the LCM of 4, 3 and 1. 1 is 1 by 1. So LCM is 4, LCM of 4, 3 and 1 is 12. So I'll get 5 into, sorry, 4 LCM of, yeah, correct, 4 3 is 12. So 5 into 3 plus now 16 into 4 minus 1 into 12. So 5 3s are 15 plus 16 4s are 64 minus 1 into 12 is 12 by 12. So I'll get 67. 15 16 7 by 12 as the answer. Exercise 11.2 question number 2. Choose the correct option and justify your choice. So first one is 2 tan 30 by 1 plus tan square 30. So this is 2 into tan 30 degree. Tan 30 degree is 1 by root 3 by 1 plus tan square 30 degree. That is 1 plus 1 by root 3 the whole square. So this is equal to 2 by root 3. I'll get in the numerator. 2 into 1 is 2. Then 1 plus, so 1 by root 3 into 1 by root 3 is 1 by 3 only. So now this is equal to 2 by root 3 divided by LCM. Now 1 means 1 by 1. LCM of 1 and 3 is 3. So if I take LCM, I'll get 3 by 3 plus 1 by 3. So this is equal to 2 by root 3 divided by 3. 3 plus 1, I'll get 4. So this is equal to 2 by root 3. So 4 by 3, if I take to the numerator, I'll get 3 by 4. Now 2 1s are 2, 2 2s are 4. Now I can 3 by 3 root 3 into 2 I have got. Now if I multiply and divide by root 3, what will I get? So I'll get 3 root 3. Now in the numerator, root 3 into 2 I'll get. So this is equal to 3 root 3. So root 3 into root 3 is 3 only. I'll be left with 2. Now 3 will get cancelled. So this is 3 root 2. So root 3 by 2 is also equal to cos 30 degree. So my option, this is root 3 by 2 is also equal to sin 60 degree. So my option is A. The next sub question is 1 minus tan square 45 by 1 plus tan square 45. So 1 minus tan square 45 is 1. So 1 plus tan square is 1. So 1 minus 1 square by 1 plus 1 square. So this is equal to 1 minus 1 square is 1 only. 1 plus 1 square is 1 only. So 1 minus 1 is 0. 0 by 2. 0 by 2 is 0. So 0 by 2. So which option is correct? D. D option is correct. The next sub question is in question number 2. Sin 2a is equal to 2 sin a is true when a is equal to how much? So now sin a is equal to sin 0 degree is 0. Okay, and also sin of 2 times of 0 degree, this comes out to be sin of 2 into 0 is 0. Again this is 0. So sin 0 and sin 2 into 0 is also 0. Therefore the first option is correct, 0 degree. The next sub question is 2 tan 30 divided by 1 minus tan square 30 is equal to, so this is equal to 2 into tan 30. Tan 30 is 1 by root 3 divided by 1 minus tan square 30, that is 1 by root 3 the whole square. So this is equal to 2 by root 3 divided by 1 minus 1 by 3. So this is equal to 2 by root 3 divided by, so if I take LCM, in the denominator 3 is the LCM, so 3 minus 1 I will get. So this is equal to 2 by root 3 So in the denominator it becomes 2 by 3. Okay, so this is 2 root 3 divided by 2 by 3. So 2 by 3, if I take to the numerator, it becomes 3 by 2. So 3 by 2, 2 will get cancelled. I'll be left with 3 by root 3. So 3 by root 3, if I multiply and divide by root 3, what will I get? So I'll get 3 root 3. 3 root 3 by root 3 into root 3 is 3 only. So this 3 will get cancelled. I'll be left with root 3. So root 3. So tan of 60 degree is also equal to root 3. So this is equal to tan of 60 degree. Exercise 11.2, question number 3. If tan of a plus b is equal to root 3 and tan of a minus b is equal to 1 by root 3 and a plus b is between 0 and 90 degree, find a and b. Okay, so given that tan a plus b is equal to root 3, we also know that tan of 60 degree is equal to root 3. That means a plus b is equal to 60 degree. And in the second case, they are given tan of a minus b is 1 by root 3. So we also note that tan of 30 degree is equal to 1 by root 3. So that means a minus b is equal to 30 degree. So this I'll take 1 and this I'll take 1. So if I solve 1 and 2, I'll get a and b. So 1 is a plus b is equal to 60 degree and 2 is a minus b is equal to 30 degree. So I'll add these two equations. So 1 plus equation 2. So b will get cancelled. So 2a is equal to 90 degree. So a is equal to 90 by 2. I'll get 45 degree. So if I put a is equal to 45 in 1, what will I get? So a I'll get 45 plus b is equal to 60 degree. So our b is equal to 60 minus 45 degree. So b is equal to 15 degree. So a is equal to 45 and b is equal to 15 degree is the answer. Exercise 11.2, question number 4. State whether the following are true or false. Justify your answer. Sub question 1 is sin of a plus b is equal to sin a plus sin b. So I'll draw one diagram. So let there be an angle A here like this. So this is angle A. Okay. Now I'll draw another angle B. Okay. From here to here it is angle B. Okay. Now I'll draw perpendicular. Okay, this is perpendicular. Let this be P, T, S, and I'll draw one perpendicular from this point also. Let this be Q and R. Now what is sine of angle A plus B? Now this whole length is angle A plus B. Right. So sine of A plus B. Now let PS be PQ. I'll take diagonal as same. Okay. Let the diagonal length be A units. So sine of A plus B is equal to opposite by adjacent. That is with respect to triangle PQR. Sine of angle A plus B is equal to opposite by adjacent, that is QR by PQ, which is equal to QR by A. Okay. Now what is sine of A plus sine of angle A plus sine of angle B? So sine A is now with respect to triangle PTS. Okay, with respect to triangle PTS, sine of angle A is ST, opposite by adjacent, that is ST by A, plus now what is sine of B? Sine of B, now from point Q I'll draw one perpendicular to PS. Okay, I'll draw one perpendicular like this to PS, and let this perpendicular meet here at M. Okay, now sine B is actually QM, opposite QM by hypotenuse, that is PQ. Okay, so this is equal to ST by A plus QM is some value, QM by PQ is also A, so LCM is A. This is ST plus QM. Now you can see that this I'll take 2 and this I'll take 1. 1 is not equal to 2, they are entirely different. Okay, so sine of A plus B is not equal to sine A plus sine B, so first statement is false. Actually one will take compulsory values from 0 to 1 only, but equation 2 can take values more than 1 also, so 1 and 2 are entirely different. Sub question 2, the value of sin theta increases as theta increases. Now in this chart you can see sin 0 is 0, sin 30 is 1 by 2 and sin 45 is 1 by root 2, sin 60 is root 3 by 2 and sin 90 is 1. So the value of sin theta is increasing. Actually you can see 1 by 2 is greater than 0, 1 by root 2 is greater than 1 by 2, and root 3 by 2 is greater than 1 by root 2, and 1 is greater than root 3 by 2. So as theta is increasing, the value of sin theta is increasing. So the second statement is true. And now coming to the third one, the value of cos theta increases as theta increases. So this again in the chart you can see, now cos 0 is 1, cos 30 is root 3 by 2, root 3 by 2 is lesser than 1, and cos 45 is 1 by root 2, 1 by root 2 is lesser than root 3 by 2, and cos 60 is 1 by 2, and 1 by 2 is lesser than 1 by root 2, 1 by 2 is lesser than all these values. Then again cos 90 you can see it is 0, so this is lesser than all these values. So as theta is increasing, what is happening to cos theta? Cos theta is decreasing actually. So the statement, the value of cos theta increases as theta increases, is false. As theta is increasing, cos theta is decreasing actually. Now the fourth sub question, sin theta is equal to cos theta for all values of theta. So this one you can see in the chart again, sin theta and cos theta should be equal. So sin theta and cos theta are equal when theta is equal to 45. You can see when theta is equal to 45, sin 45 is 1 by root 2, and when cos and theta is equal to 45, cos 45 also is equal to 1 by root 2. For all other values, for all other theta values, it is different. Only for theta is equal to 45, sin theta and cos theta is equal and equal to 1 by root 2. So the statement sin theta is equal to cos theta for all values of theta, this is false. So cot A is not defined for A is equal to, angle A is equal to 0 degree. So cot A in this chart you can see for theta is equal to 0, that means when angle A is equal to 0, cot A is not defined. So actually we will get here 1 by 0 which is not defined. So tan 90 is not defined, that is 1 by 0 we get. Same thing, same value we get here also, 1 by 0 it is, which is not defined. So the last statement, cot A is not defined for A is equal to 0 is true. Second sub question is true, third sub question is false, fourth one is false, and fifth one is true. And that completes this exercise problem. The next topic in this chapter is trigonometric ratios of complementary angles. Now consider this figure: triangle AB, right angle triangle ABC, right angled at angle B. Okay, angle B is 90 degree. Now what is the relation between angle A and angle C? They are complementary angles. That means angle A plus angle C is 90 degree. Okay, how? Now sum of all the angles is equal to 180 degree, right? So angle A plus angle B plus angle C is equal to 180 degree. So angle B, we already know it is 90 degree. So angle A plus 90 degree plus angle C is equal to 180 degree. So angle A plus angle C is equal to, now if I'll bring 90 to the right hand side, so 180 minus 90, so this I'll get 90 degree. So when sum of two angles is equal to 90 degree, they are said to be complementary angles. So angle A and angle C are complementary angles. Now what is angle C? Angle C is equal to 90 minus angle A. Okay, angle C is equal to 90 minus angle A. If I bring this to the right hand side. Now coming to the figure in triangle ABC, with respect to angle A, what is sin A? Sin A, sin of angle A is given by opposite by adjacent. This is opposite, this is adjacent with respect to angle A, and this is hypotenuse. So sin A is opposite by adjacent with respect to angle A. Sorry, opposite by hypotenuse. Okay, so that is BC by AC. So BC by AC is also equal to cos of C with respect to angle C. With respect to angle C, BC by AC is cos of angle C. So cos of angle C is 90 minus angle A. Okay, this 90 minus angle A. Now similarly, what is cos of angle A? With respect to angle A, cos of angle A is adjacent by hypotenuse. Adjacent by hypotenuse, that is AB by AC. So AB by AC is also equal to sin of angle C. With respect to angle C, AB by AC is sin C, sin of angle C. So that is sin of angle C is equal to 90 minus angle A. Similarly, tan of angle A, tan angle A is equal to opposite by adjacent. With respect to angle A, opposite side is BC and adjacent side is AB. So BC by AB is also equal to cot of angle C. With respect to angle C, BC by AB is cot C. So this I can write as cot of 90 minus angle A. Similarly, cot of angle A, with respect to angle A, cot of angle A is adjacent by opposite, which is equal to AB by BC. But AB by BC is also equal to tan of angle C. With respect to angle C, AB by BC is tan C. So this is equal to tan of angle C is 90 minus angle A. Similarly, secant of angle A, with respect to angle A, secant A is hypotenuse divided by adjacent side. Okay, so that is AC by AB. But AC by AB is also equal to cosecant of angle C. with respect to angle C, AC by AB is cosecant angle C, cosecant of angle C. So this is equal to cosecant of 90 minus angle A. Similarly, cosecant of angle A with respect to angle A, cosecant of angle A is hypotenuse by opposite. So this is equal to AC by BC, but AC by BC is secant with respect to angle C. AC by BC is secant of C, secant of angle C. So this is equal to secant of angle C is nothing but 90 minus angle A. Okay. So this is the trigonometric ratio of complementary angles. So when that means sine will change to cos. Now in the first case you can see sine is changing to cos. Sine of angle A is equal to cos of 90 degree minus angle A. Similarly, cos is changing to sine in the second case. Cos A is equal to sine of 90 minus angle A. And in the third case you can see tan of angle A. Tan will change to cot. Tan of angle A is equal to cot of 90 minus angle A. Similarly, cot of angle A is equal to tan of 90 minus angle A. Secant of angle A is equal to cosecant of 90 minus angle A. And cosecant of angle A is equal to secant of 90 minus angle A. Sine will change to cos, cos will change to sine, tan will change to cot, cot will change to tan, and secant will change to cosecant, and cosecant will change to secant. So this is the relation in complementary angles. There are some worked examples in the textbook. Go through it. All are self-explanatory. I'll be directly solving exercise problem. Now exercise 11.3. First question. First sub question. Evaluate sine of 18 degree by cos of 72 degree. Now in this problem you can see 18 plus 72 is 90 degree. So in the numerator what I will do is I will write sine of 18 degree as sine of I can write cos of 90 minus 72 degree. Okay, and then in the denominator, sorry, this is a sine. So 18 I am writing as 90 minus 72. In the denominator I will written as it is cos of 72 degree. Now sine of 90 minus 72 degree. Sine of 90 minus 72 degree is cos of 72 degree. Cos of 72 degree by cos of 72 degree. Both will get cancelled. Answer is 1. Second sub question. So tan of 26 degree by cot of 64 degree. So here now 26 by 64 I will get 90. They are complementary. So therefore what I will do in the numerator I will make some changes. Tan. So in place of 26 I will write as 90 minus 64. Okay. 90 degree minus 64 minus cot of 64 degree. So but now tan of 90 minus 64 degree is cot of 64 degree. And in the denominator as it is cot 64 degree I will get. So both will get cancelled. Answer is 1. And third sub question. Cos 48 degree minus sine of 42 degree. So here you can check 48 plus 42 is equal to 90 I will get. So cos of 48 I can write as cos of 90 minus 42 minus sin 42 degree. So this will get us cos of 92, cos of 92, 90 minus 42 degrees, sin of 42 degrees, sin of 42 degree minus sin of 42 degree. So both will get cancelled. I'll get answer 0. Fourth sub question. Cosecant 31 minus secant 59. Evaluate this one. So here we can see 31 plus 59 is equal to 90. So they are complementing. So that means now cosecant 31 I'll write as 90 minus 31 degree, sorry, 90 minus 59 degree minus secant 59 degree. I'll write as it is secant 59 degree. Now cosecant 90 minus 59 is secant of 59 degree minus secant of 59 degree. Both will get cancelled. I'll get 0 as the answer. Exercise 11.3, question number 2. Show that, first sub question, show that tan of 48 degree into tan of 23 degree into tan of 42 degree into tan of 67 degree is equal to 1. Now here you can, if you check tan 48 and tan 42, they are complementary angles. 48 plus 42 is 90 degree, and similarly 23 and 67, 23 plus 67, they are also complementary. So I'll write reorder it, tan 48 degree into tan 42 degree. I'm reordering, I'm making no changes, into tan 23 degree into tan of 67 degree is equal to, okay, I'm reordering and writing. Okay, first I'll take left hand side. Now tan of 48 degree, tan of 48 degree I can write as tan of 90 minus 42 degree, and tan 42 degree I'll write as it is 42 degree into, now tan of 23 degree I can write as tan of 90 degree minus 67 degree, and tan of 67 degree I'll write as it is. Now left hand side is equal to, now tan of 92 degree into tan of 90 degree minus 42 degree I can write as cot of 42 degree. Okay, tan changes to cot. So this is tan 42 degree into, sorry, cot 42 degree into tan 42 degree into, now tan of 90 degree minus 67 degree, here also it's tan will change to cot. I can write as cot of 67 degree into tan of 67 degree. Now what is the relation between cot and tangent? Tan theta is equal to 1 by cot theta. Okay, they are inversely related. Okay, so now cot of 42 I can write as 1 by tan 42 degree into tan 42 degree I'll write as it is. Now here also cot 42 degree I can write as 1 by tan 67 degree. So here tan 67 degree I'll write as it is. Now here these two will get cancelled, these two will get cancelled. I'll get 1, which is equal to right hand side. So I should prove left hand side is equal to right hand side. I have done. Second sub question, cos 38 degree into cos 52 degree minus sin of 38 degree into sin of 52 degree is equal to 0. Now here you can see that 38 plus 52 is equal to 90. So they are complementing. So that means now left hand side I can write as cos 38 degree I can write as 90 minus 52. Okay, 90 degree minus 52 degree into cos of 52 degree, I'll write as it is. Now sin 38 degree, sin of 38 degree I can write as 90 minus 52. 90 degree minus 52 degree minus into sin of 52 degree as it is. Now this is equal to, now cos of 90 degree minus 52 degree, cos changes to sin in place of complementary angles. So cos becomes sin, sin of 52 degree, sin of 52 degree into cos of 52 degree minus. So here also sin will change to cos because they are complementary angles. So sin 90 degree minus 52 degree is cos of 52 degree into sin of 52 degree. Now you can check first term and second term both are same only. Okay, both first term or second term are same only, so they will get cancelled and answer I'll get 0. Exercise 11.3, third question. If tan of 2a is equal to cot of a minus 18 degree, where 2a is an acute angle, find the value of angle A. Okay, now tan of 2a, left hand side I'll write as it is. Now in the right hand side I can write as tan of 90 minus a minus 18. Okay, because cot of a is equal to tan of 90 minus a. Okay, therefore right hand side I can write as tan of 90 minus of a minus 18. So left hand side and right hand side both are same only. Okay, that means I can equate the angles. So 2a is equal to 90 minus a minus 18 I can write, or 2a is equal to, now I'll open the bracket, 90 minus a plus 18. Now I'll bring this a to the left hand side. 2a plus 1a is equal to 90 plus 18. So 3a is equal to 90, 100, 108. So a is equal to 108 by 3. 3 3s are 9, 3 6 are 18. So a is equal to 36 degree I'll get. Exercise 11.3, question number 4. If tan A is equal to cot B, prove that a plus b is equal to 90 degree. So given tan A is equal to cot B, so tan A, so right hand side I'll write cot B, I can write as tan of 90 minus b, because cot theta is equal to tan of 90 minus theta. Okay, so here cot B I can write as 90 minus cot B as I can write as tan of 90 minus angle B. Okay, so here left hand side and right hand side both are same, therefore I can equate the angles. So A is equal to 90 minus B. So if I take B to the left hand side, A plus B is equal to 90 I'll get. Fifth sub question, if secant 4a is equal to cosecant of a minus 20 degree, where 4a is an acute angle, find the value of a. So we know that cosecant theta is equal to secant of 90 minus theta. Okay, therefore secant 4a, right hand side I can write as, instead of cosecant I can take secant, but here I should write 90 minus a minus 90, sorry, a minus 20. Okay, cosecant theta is equal to secant of 90 minus theta. Therefore, cosecant of a minus 20 is equal to secant of 90 minus a minus 20. So both left hand side and right hand side are same. So I can equate the angles. So 4a is equal to 90 minus a minus 20. Now 4a is equal to 90. I'll open the bracket, minus a plus 20 I'll get. Okay, now I'll bring a to the left hand side. 4a plus a is equal to 90 plus 20. 90 plus 20 is 100, 110. So 5a is equal to 110. Therefore a is equal to 110 divided by 5. So how much I will get? 5 2s are 10. Then 5 2s are 10. So 22 degree. So angle A is equal to 22 degree is the answer. The next question in this exercise is question number 6. If ABC are interior angles of a triangle ABC, then show that sine of B plus C by 2 is equal to cos of A by 2. So in any triangle, sum of three angles will be equal to 180 degree, right? So I can equate it like this. Now I'll divide both sides by 2. So A plus B plus C by 2 is equal to 180 by 2. So now A plus B plus C by 2 is equal to 90 degree I will get. Now left hand side I can write B plus C by 2 plus A by 2 I can write is equal to 90 degree. Now I will bring this to the right hand side. B plus C by 2 is equal to 90 degree minus A by 2. Now B plus C by 2 is equal to 90 degree minus A by 2. Now taking sine both sides. Taking sine both sides. That means I'll take sine of B plus C on the left hand side, and on the right hand side I'll take sine of 90 degree minus A by 2. Now this is sine of B plus C by 2. So right hand side, it's complementary angle. So I can change sine to cos. I can write this as cos of A by 2, because sin theta is equal to cos of 90 minus theta. Okay, or sine of 90 minus theta is equal to cos theta, right? Therefore here sine will change to cos of A by 2 I'll get in the right hand side. Seventh question in this exercise, express 67 degree sine of 67 degree plus cos of 75 degree in terms of trigonometric ratios of angles between 0 degree and 45 degree. So sine of 67 degree plus cos of 75 degree. So now this one I can write as sine 67 degree. I can write as, see, 90 minus 67. What is 90 minus 67? 90 minus 67 I'll get 23 3 2. Okay, so sine of 67 degree I can write as cos of 90 minus 23 degree. Okay, and cos of 75 degree I can write as, now 90 minus 75 degree is how much? 15 degree. So cos of 75 degree I can write as cos of 90 minus 15. Sorry, here it should be sine only. Okay, now sine of 90 minus 23 degrees, cos of 23 degree, plus cos of 90 minus 15 degrees, sine of 15 degree, and that completes. Because why? We know that sine 90 minus theta is equal to cos of theta. Similarly, cos of 90 minus theta is equal to sin theta. And that completes this problem and this exercise. The next topic in trigonometry is trigonometric identities. Now consider a right angle triangle ABC in which angle B is equal to 90 degree. So with respect to angle A, AC is the hypotenuse and AB is the adjacent side and BC is the opposite side. Now applying Pythagoras theorem, I get AC square is equal to AB square plus BC square. AB square plus BC square. I'll mark this as 1. Now if I divide equation 1 by AC square, what will I get? If I divide 1 throughout by AC square, the value will not change. Therefore, AC square by AC square is equal to AB square plus BC square by AC square. Now this is equal to AC by AC, the whole square I can write here in the left hand side. Now this I can write AB by AC, AB square plus by AC square plus, I am splitting that's it. Okay, BC square by AC square. Now this I can write as AB by AC the whole square plus BC by AC the whole square. Now AB by AC is nothing but cos A. Okay, cos A with respect to angle A. AB by AC is cos A. Therefore, AB by AC the whole square is cos square A plus. Now BC by AC, opposite by hypotenuse, is nothing but sine of A. Therefore, BC by AC the whole square is sine square A. Now AC by AC will get cancelled in the left hand side and will get 1. Okay, these two will get cancelled, will get 1. So 1 is equal to cos square A plus sin square A, or cos square A plus sin square A is equal to 1. So this is one identity. Now similarly, I'll take equation 1, AC square is equal to AB square plus BC square. Now I'll divide throughout by AB square. If I divide, okay, by AB square, what will I get? AC square by AB square is equal to AB square plus BC square by AB square. So this is equal to, now I can split the right hand side, AB square by AB square plus BC square by AB square. Now with respect to angle A, okay, still I will simplify further. This I can write as AB by AB the whole square plus BC by AB the whole square. Now AB by AB and AB will get cancelled and this becomes 1. In the left hand side, okay, AC by AB the whole square I can write. Now AB in the right hand side, AB by AB the whole square becomes 1 plus, now BC by AB is nothing but tan A. With respect to angle A, BC by AB is tan A. So tan A. Therefore BC by AB the whole square is tan square A I'll get. And in the left hand side, AC by AB. AC by AB is nothing but secant. Hypotenuse by adjacent is nothing but secant A. Therefore, AC by AB is secant. AC by AB the whole square is secant square A I'll get. So secant square is equal to 1 plus tan square A. So this is the second identity. And we'll get one more identity. Now equation 1 is AC square is equal to AB square plus BC square. Okay. Now divide 1 by BC square. What will I get? AC by BC. AC square by BC square is equal to AB square plus BC square by BC square. So this is equal to AB by BC. I am splitting the whole square plus BC by BC the whole square. So this I will get. So AB by BC with respect to angle A, AB by BC is cot A. So here AB by BC the whole square is cot square A I will get. BC by BC will get cancelled. Both numerator and denominator are equal. BC by BC I will get 1. So 1 square. And in the left hand side, AC by BC the whole square. AC by BC, the AC is hypotenuse, BC is opposite side. So hypotenuse by opposite side is cosecant square. Okay. Cosecant A. So AC by BC the whole square is cosecant square A I will get. Cosecant square A is equal to 1 plus cot square A. So A, B and C are the three identities. Now using these identities, there are many worked examples in the textbook, and also some exercise problems are there. We'll proceed and do it. Okay. In the textbook you can see that how they derived cos square A plus sin square A is equal to 1 plus tan square A is equal to secant square A, and cot square A plus 1 is equal to cosecant square A. And there are some worked examples here. All are self-explanatory. You can read it by yourself. First time you may not understand, but when you go through it again and again, you will definitely understand it. Now I'll be solving exercise problems. Exercise 11.4, question number 1. Express the trigonometric ratios sin A, secant A and tan A in terms of cot A. So sin A I should express in terms of cot A, then secant A I should express in terms of cot A, and also tan A I should express in terms of cot A. So in any triangle, right angle triangle, so let us say this is A, this is B and this point is C. Now with respect to angle A, what is tan A? With respect to angle A, this is opposite, this is adjacent, and this is hypotenuse. Okay. Now tan A is opposite by adjacent. But what is adjacent? Adjacent by opposite. Adjacent by opposite is nothing but cot A. So tan A, cot A are inversely related. Tan A is equal to 1 by cot A. Okay. Tan A is opposite by adjacent. Cot A is adjacent by opposite. So tan A, if I want to express in terms of cot A, it is simply 1 by cot A. That's it. Now sin A I should express in terms of cot A. Now we know the trigonometric identity that sin square A plus cot square A is equal to 1, right? This is one of the trigonometric identity. Now I'll bring this sin square A plus cos square A. Okay, sorry, this is cos square A. Now I'll bring this to the right hand side. So Sin square A is equal to 1 minus cos square A. I'll get, if I take square root, sin square A is equal to, sin A is equal to square root of 1 minus cos square A I'll get. So what is cos? So 1 minus cos is nothing but 1 by secant A. So this is 1 by secant square A I'll get. Okay, now this is equal to square root of 1 minus secant square A. What is secant square A? Secant square is, there is another identity. What is that identity? 1 plus tan square A is equal to secant square A. This is one of the identity. I'll substitute that 1 plus tan square A. In place of secant square A, I'll write 1 plus tan square A. Now this is equal to square root of 1 minus 1 by 1 plus, now tan square A is nothing but 1 by cot square A. Tan is 1 by tan A is 1 by cot A. Now tan square A becomes 1 by cot square A. Now this is equal to 1 minus 1 by, now I'll take the LCM. I'll write one more step. So here 1 means it is 1 by 1 plus 1 by cot square A. Now if I can take the LCM there, now this is equal to square root of 1 minus 1 by LCM of 1 and cot square is cot square A. So I'll get cot square A plus 1 by cot square A. Now in the numerator 1 is there, 1 means it is 1 by 1. Okay, now this is equal to square root of 1 minus, so 1 by 1 I'll write as it is. So cot square A plus 1 by cot square A, I'll take to numerator. When I'll take to numerator, cot square A will come top, that is in the numerator, and cot square A plus 1 will come here. So this is equal to again 1 minus 1 into cot square A is cot square A only. So 1 into cot square A plus 1 is 1 cot square A plus 1. Again here I can take LCM. Here if I take LCM, so in the first term 1 means it is 1 by 1. So if I take LCM, I'll get cot square A plus 1. LCM of 1 and cot square A plus 1 is cot square A plus 1. So I'll get cot square A plus 1 minus cot square A. So here cot square A will get cancelled. So I'll get square root of 1 by 1 plus cot square A as the answer. So sin A is also equal to square root of 1 by 1 plus cot square A. So the third one we proved there. This is the first one which we proved. Now we should prove that we should express secant A in terms of cot A. So we know that 1 plus tan square A is equal to secant square A, right? We already know this. Therefore, I'll write like this: secant square A is equal to 1 plus tan square A. Therefore, secant A is equal to square root of 1 plus tan square A. Now secant A is equal to square root of 1 plus tan is 1 by cot. So here it becomes cot square A. So now this is equal to square root of I'll take LCM. If I take LCM, I'll get cot square A in the denominator. In the numerator, cot square A plus 1 I will get. So now this is equal to secant A is equal to, in the numerator, 1 plus cot square A remains as it is. Okay, and cot square A. So square root of cot square A is cot A. So secant A will finally become square root of 1 plus cot square A by cot A. So there are too much information here in this single page only. Exercise 11.4, question number 2. Write all the other trigonometric ratios of angle A in terms of secant A. So we know that sin square A is equal to 1 minus square root of 1 minus cos square A. How we got? From this identity, sin square A plus cos square A is equal to 1. Therefore sin square A is equal to 1 minus cos square A, or sin A is equal to square root of 1 minus cos square A. So now what is cos? Cos is 1 by secant. So this is equal to 1 minus 1 by secant square A I will get. Okay, sin A is equal to square root of 1 minus 1 by secant square A. Or you can further simplify. You can take LCM now. Secant square A minus 1 by secant square A. So this is equal to secant square A minus 1 by secant A. In the denominator, only secant A I will get. So square root of secant square A is just secant A. So sin A is square root of secant square A minus 1 by secant A. Now cos A. Cos A is defined by 1 by secant A. So this is simple. What is cos A? Cos A is adjacent by hypotenuse. But what is secant A? Secant A is hypotenuse by adjacent. So they are inversely related. Cos A is equal to 1 by sin A. Next, tan A. Tan A is equal to square root of secant square A minus 1. How? Because there is an identity. What is the identity? 1 plus tan square A is equal to secant square A. So therefore, if I bring 1 to the right hand side and simplify, tan square A is equal to secant square A minus 1 I will get. Therefore tan A is equal to square root of secant square A minus 1. Okay, now this is over, this is over, this is over. Now cot A I should express. Now cot A is equal to, cot A is 1 by tan A. So tan A already we found out. So this becomes cot A is equal to 1 by square root of secant square A minus 1. This is over. Now secant A is secant A only. Cosecant A I should express now. Cosecant A is equal to, cosecant is 1 by sin A. Sin A we already found out. Sin A is square root of secant square A minus 1 by secant A. So cosecant A is 1 by sin A is square root of secant square A minus 1 by secant A. So in the numerator 1 is there. 1 means it is 1 by 1. So this is equal to 1 by 1 into, now denominator, if I take to the numerator, secant a will come to the numerator, and this one will remain in the denominator, that is square root of secant square a minus 1, or this is equal to secant a by square root of secant square a minus 1, or simply secant a already we have found out, just inverse it, take bring the numerator to the denominator and denominator to the numerator, that, and we will get the answer. Exercise 11.4, question number 3, evaluate. First sub question, sin square 63 plus sin square 27 by cos square 17 degree plus cos square 73 degree. Now here we can see 63 plus 27, I am getting 90. Okay, so in sin square I will write 63 as 90 minus 27, okay, plus sin square 27 divided by cos square, here in the numerator I will write 17, I will write as, so 17 plus 73 I will get 19. So here I will write 9 in place of 17 degree, I will write 90 minus 90 minus 73, 90 degree minus 73 degree plus cos square 73 degree. Now sin square of 90 minus 27 is cos square 27 plus sin square 27. Why? Sin of 90 minus theta is equal to cos theta. We have learned this in complementary angles, okay, in trigonometric ratios of complementary angles we learned this one. Similarly, cos of 90 minus theta is equal to sin theta. Sin will change to cos, cos will change to sin. So here similarly sin square 90 minus 27 I got as cos square 27. So in the denominator cos square of 90 minus 73 is there, so I will get sin square of 73 degree plus cos square of 73 degree. Now according to identity, trigonometric identity, what is sin square theta plus cos square theta this is equal to 1. Therefore here cos square 27 degree plus sin square 27 degree is 1 I will get. Similarly in the denominator also sin square 73 degree plus cos square 73 degree I will get 1. So 1 by 1 is equal to 1. Second sub question, the given question is sin 25 degree cos 65 degree plus cos 25 degree into sin 65 degree. So here the sin, so 25 plus 65 I will get 90. So what I will do is in place of 25 I will write 90 degree minus 65 degree into cos 65 degree plus, here also cos 25 degree is there, I will write 90 minus 65 degree into sin 65 degree. Okay, now sin of 90 minus 65 degree is cos 65 degree I will get. Why? Sin 90 minus theta is equal to cos theta. Similarly cos of 90 minus theta is equal to sin theta. So cos 65 into cos 65 degree plus, here I will get cos Okay, here it will change. Okay, cos will change to sine. Sine 65 degree I'll get into sine of 65 degree. So cos 65 degree into cos 65 degree is cos square 65 degree plus sine 65 degree into sine 65 degrees sine square 65 degree. So here this is equal to 1. Why? Because sine square theta plus cos square theta is equal to 1. We learned this in trigonometric identity. Okay. Exercise 11.4, question number 4, sub question 1. Choose the correct option, justify your choice. Okay. 9 secant square a minus 9 tan square a is equal to how much? So this is equal to, now secant square a, 1 plus tan square a is equal to secant square a. We learned this in trigonometric identities. So 9 into secant square a I'll write as 1 plus tan square a minus 9 into tan square a. So this is equal to, now I'll open the bracket. 9 into 1 is 9 plus 9 into tan square a is 9 tan square a minus 9 tan square a. So plus 9 tan square a minus 9 tan square a will get cancelled. I'll get answer 9. So the correct option is B. So second sub question, 1 plus tan theta plus secant theta into 1 plus cot theta minus cosecant theta. What is the value of this thing? So there are some options, 0, 1, 2 and minus 1. So this is equal to, now I'll express tan theta, cot theta and secant theta in terms of sine and cos. So tan theta is sine theta by cos theta plus secant theta is 1 by cos theta into 1 plus cot theta is cos theta by sine theta minus cos theta is 1 by secant theta. So now I'll take LCM cos theta. So here 1 means 1 by 1. LCM of 1 and cos theta is cos theta. So cos theta plus sin theta plus 1 I'll get here into, so here also 1 means 1 by 1. So here, okay, I have made one mistake here. This is sin theta. Okay, now here LCM is sin theta. So I'll get sin theta plus cos theta minus 1. So denominator I can multiply sin theta into cos theta is sin theta cos theta in the numerator. Now you can see in the numerator cos theta plus sin theta plus 1 into sin theta plus cos theta minus 1 is there. Now what is a plus b into a minus b? This is equal to a square minus b square. Now here I'll group sin theta plus cos theta. Okay, so sin theta plus cos theta plus 1 into sin theta plus cos theta minus 1 is there. Therefore, according to this identity here, this becomes cos theta plus sin theta the whole square minus 1 the whole square. Okay. Now we also know that a plus b the whole square is equal to a square plus b square plus 2ab. Therefore, cos theta plus sin theta the whole square I'll expand now. So I'll get cos square theta plus sin square theta plus 2 into cos theta sin theta minus 1 square is 1 only. the whole divided by sin theta cos theta. Now we know that sin square theta plus cos square theta is equal to 1. Therefore this term, this will become 1. So 1 plus 2 into cos theta sin theta minus 1 by sin theta cos theta. So plus 1 minus 1 will get cancelled. I am left with 2 cos theta sin theta by sin theta cos theta. So sin theta cos theta will get cancelled. I will be left with 2. So the third option, option C, is correct. Exercise 11.4, fourth question, sub question 3. Secant A plus tan A into 1 minus sin A. What is the value of this one? Now I will open the bracket and open the bracket. When I open the bracket, secant A plus tan A into 1 minus secant A plus tan A into sin A I will get. So again I will further open the bracket. So secant A plus tan A, 1 into secant A plus tan A is secant A plus tan A only, minus, now here I will get secant A into sin A minus tan A sin A I will get. Okay, now this is equal to secant A plus tan A. Here secant A is 1 by cos A. Okay, cos A, sin A as it is I am writing. So here tan A is sin A by cos A into sin A as it is. So this is equal to secant A plus tan A. Now here sin A by cos A I'll get. Okay, sin A by cos A is tan A. This I'll get as tan A minus, now here sin A into sin A is sin square by A by cos A. So this is equal to, now plus tan A minus tan A will get cancelled. Now secant A I can write as 1 by cos A minus sin square A by cos A. Okay, now if I take the LCM, cos A is common, so 1 minus sin square A. So what is 1 minus sin square A? 1 minus sin square A is cos square A by cos A. Why 1 minus sin square A is cos square A? Sin square theta plus cos square theta is equal to 1. Therefore cos square theta is equal to 1 minus sin square theta. Okay, this is the trigonometric identity which we already learnt. Okay, therefore here 1 minus sin square A is cos square A. Now here cos and this power of 2 will get cancelled, so cos A will be left. Exercise 11.4, fourth question, last sub question. What is the value of 1 plus tan square A by 1 plus cot square A? So 1 plus tan square A is nothing but secant square A. This is the one of the identity. 1 plus tan square A is equal to secant square A, and 1 plus cot square A is cosecant square A. This we learnt in trigonometric identities. Okay, now sin square A I can write as, I'll express both secant square A and cosecant square A in terms of sin A and cos A. So sin A is 1 by cos A, so 1 by cos square A I'll get in place of secant square A. Okay, into 1 by cos square a, 1 by cosecant square a, okay, 1 by cosecant square a. I just reordered it and I wrote secant square a is equal to 1 by cos square a. Now this is equal to 1 by cos square a. So cosecant square a is sin square a. So that will come in the numerator. Sin square a by 1 I will get. See, cosecant a is equal to 1 by sin a. Okay, or I'll give you one more step because you'll get confused. So cos square a into, I'll write cosecant square a is 1 by sin square a. Now here this is 1 by cos square a is equal to, now in the numerator 1 is there, 1 means it is 1 by 1, so into 1 by 1. Now in the denominator 1 by sin square a is there, I can take to numerator. When I take to numerator, sin square a will come to the top and 1 will come down. Now 1 into sin square a is sin square a. Cos square a into 1 is cos square a. So this is equal to tan square a. Sin by cos is tan. So sin square by cos square a is tan square a. Exercise 11.4, question number 5. Prove the following identities where the angles involved are acute angles for which the expressions are defined. So first sub question, cosecant theta minus cot theta the whole square is equal to 1 minus cos theta by 1 plus cos theta. I should prove that left hand side is equal to right hand side. Now I'll express all in terms of sin theta and cos theta. So cosecant theta is 1 by sin theta minus cot theta is cos theta by sin theta. So left hand side is this thing, the whole square. Now if I take LCM is sin theta only, so 1 minus cos theta the whole square I'll get. Okay, so this is equal to, the denominator I'll get sin square theta numerator I'll write as it is 1 minus cos theta the whole square. Now this is equal to, now denominator sin square theta I can write as 1 minus cos square theta, because from identity we know that sin square theta plus cos square theta is equal to 1. Therefore sin square theta is equal to 1 minus cos square theta. So numerator I'll write as it is 1 minus cos theta the whole square. Now here 1 is, I can write as 1 square. Okay, now what is a square minus b square? A square minus b square is equal to a plus b into a minus b, right? Therefore numerator I'll write as it is 1 minus cos theta the whole square. So denominator 1 square minus cos square theta I can write as a plus b, that is 1 plus cos theta into 1 minus cos theta. Now here 1 minus cos theta, 1 minus cos theta will get cancelled. So this will get cancelled and this power of 2 will get cancelled. I will be left with 1 minus cos theta by 1 plus cos theta. This is equal to right hand side. So I started with the left hand side and proved that left hand side is equal to right hand side. Exercise 11.4, question number 5, sub question 2. Prove that cos a by 1 plus sin a plus 1 plus sin a by cos a is equal to 2 secant a. So I'll start with left hand side. I'll take the LCM. Okay, now if I take LCM, 1 plus sin a into cos a. LCM is 1 plus sin a into cos a. So in the first term, in the numerator, cos a into cos a, I'll get plus here 1 plus sin a into 1 plus sin a, I'll get. So this is equal to, now cos a into cos a is cos square a, plus 1 plus sin a into 1 plus sin a is 1 plus sin a the whole square, divided by 1 plus sin a into cos a. Now this is equal to cos square a, plus 1 plus sin a the whole square is, what is a plus b the whole square? This is equal to a square plus b square plus 2ab. So I'll expand this one. So 1 plus sin a the whole square is 1 square plus sin square a plus 2 into 1 into sin a the whole divided by 1 plus sin a into cos a. So now this is equal to, now you can see cos square a plus sin square a is 1. Okay, I'll write one more step. Cos square a plus sin square a, I wrote it side by side, plus 1 square means 1 only, plus 2 into 1 into sin a is 2 sin a, 2 on the 2 into sin a is 2 sin a, divided by 1 plus sin a into cos a. Now cos square a plus sin square a, this value is equal to 1. So 1 plus 1 plus 2 sin a by 1 plus sin a into cos a. So this is equal to 1 plus 1 is 2, 2 plus 2 sin a divided by 1 plus sin a into cos a. So this is equal to, I'll take 2 common factor in the numerator. If I take 2, I'll get 1 plus sin a by 1 plus sin a into cos a. So 1 plus sin a will get cancelled. I'll be left with 2 by cos a. So cos a is secant a, 1 by secant a, therefore, or 1 by cos a is secant a. So this I can write as 2 into secant a. So this is equal to right hand side. Exercise 11.4, question number 5, sub question 3. Prove that tan theta by 1 minus cot theta plus cot theta by 1 minus tan theta is equal to 1 plus secant theta into cosecant theta. So they have given the hint also, write the expression in terms of sin theta and cos theta. So I'll start with left hand side. So tan theta, I'll write sin theta by cos theta by 1 minus cot theta is cos theta by sin theta plus cot theta is cos theta by sin theta by 1 minus tan theta is sin theta by cos theta. So now this is equal to sin theta by cos theta. Here if I take LCM, I'll get sin theta. 1 means it is 1 by 1, okay, here also. Then I'll get sin theta minus cos theta plus here cos theta by sin theta. So here also I'll take LCM, cos theta in the denominator, so cos theta minus sin theta I'll get. So in the first term sin theta by cos theta. So the denominator I can take to numerator. When I take it, sin theta will go up and this sin theta minus cos theta will come down in the denominator. Here also same thing. Cos theta by sin theta, which was there in the numerator, I'll write as it is. Denominator I'll take to numerator. So this becomes now cos theta into cos theta minus sin theta. This part if I take to numerator, it will interchange. Here also this part when I take to numerator, it will get interchanged. That means denominator will go to numerator and numerator will come to denominator. So now here sin theta into sin theta is sin square theta divided by cos theta into sin theta minus cos theta, plus here cos theta into cos theta is cos square theta by sin theta into cos theta minus sin theta will get. Now you can see this is first term, this is second term. In both the term, 1 by cos theta minus sin theta is common. This is common in both first and second term. So I'll take it separately. So I'm left with in the first term I'm left with sin square theta by cos theta, and in the second term. So before this one more step I'll write because you'll get confused. So sin square theta by cos theta into sin theta minus cos theta is there. In the second term I'll make some small modification. Numerator I'll keep it as it is, cos square theta. In the denominator what I'll do is I'll interchange these two. Okay, these two I'll interchange and I'll write as sin theta minus cos theta. So I'll take minus 1 as common factor. So like this I'll write. Okay, this is plus. Now again I can rearrange. I can write as sin square theta by cos theta into sin theta minus cos theta. Now here my minus I have taken outside. So this minus I can write here, plus into minus I'll get minus here. So cos square theta by I'll get sin theta into sin theta minus cos theta. Okay. Now if you see, there are two terms and 1 by sin theta minus cos theta is common between these two terms. That one common term I'll take outside, that is 1 by sin theta minus cos theta I'll take outside, and I'm left with sin square theta by cos theta minus cos square theta by sin theta. Now this is equal to 1 by sin theta minus cos theta into, now here I'll take LCM. LCM of sin theta cos and cos theta is sin theta cos theta. Sin theta cos theta. So here it becomes in the first term sin cube theta minus cos cube theta. Now what is the expansion of a cube minus b cube? a cube minus b cube is equal to a minus b into a square plus b square plus ab. Okay, now using that one I'll expand this one, 1 by sin theta minus cos theta. So now sin cube minus cos cube I can expand, so now this becomes sin theta minus cos theta into sin square theta into sin square theta plus cos square theta plus 2 into sin theta cos theta. I'll get divided by sin theta cos theta. Now here sin theta minus cos theta will get cancelled. Now I am left with sin square theta plus cos square theta plus 2 sin theta cos theta by sin theta cos theta. Now sin theta plus cos theta, this one is 1. Okay, so 1 plus so 1 plus 2 sin theta cos theta by sin theta cos theta. Now I'll split this one, 1 by sin theta cos theta plus 2 sin theta cos theta by sin theta cos theta. So 1 by sin theta is secant theta, sorry, cosecant theta, and 1 by cos theta is secant theta. So this is equal to secant theta into cosecant theta, plus here sin theta cos theta will get cancelled, plus 1, sorry, this is 1, actually this is 1, this is 1 here, this is 1, so ultimately I'll get 1 plus secant theta into cosecant theta. Expansion of a cube minus b cube is equal to a minus b into a square plus b square plus ab. Therefore sin cube theta minus cos cube theta is sin theta minus cos theta into sin square theta plus cos square theta plus sin theta cos theta. Exercise 11.4, question number 5, sub question 4. Prove that 1 plus secant a by secant a is equal to sin square a by 1 minus cos a. They have given a hint also. Simplify left hand side and right hand side separately. So left hand side I will take, it is given 1 plus secant a by secant a. So this is equal to, now what I will do is, in place of secant a I will write 1 by cos a. So secant a is 1 by cos a by 1 by cos a, 1 by cos a. So this is equal to, now I will take LCM, cos a by cos a plus 1 by cos a by 1 by cos a. Now the denominator I will take to numerator, so cos a plus 1 by cos a. When I take denominator to the numerator, it becomes cos a by 1. 1 by cos a becomes cos a by 1. So cos a will get cancelled. I will be left with 1 plus cos a. 1 plus cos a by 1 is 1 plus cos a only. Now right hand side, if I take, what is the right hand side? Right hand side is sin square a by 1 minus cos a. So what I will do is, I will multiply both numerator and denominator by 1 plus cos a, 1 plus cos a into 1 plus cos a. So when I multiply like this, there effectively there is no change. I'm making no change. Okay, so now this is equal to sin square into 1 plus cos a. Now this is denominator, you can see it is in the form of a minus b into a plus b. So a plus b into a minus b is a square minus b square. So here now I can write this one as 1 square minus cos square a. So now this is equal to 1 sin square a into 1 plus cos a. So 1 minus cos square a is sin square a. Okay, sin square will get cancelled. I will be left with 1 plus cos a only. So now you can see both left hand side and right hand side is equal to is equal. Okay, therefore 1 is equal to 2. Therefore LHS is equal to RHS. Okay. Exercise 11.4, question number 5, sub question 5. The given question is cos a minus sin a plus 1 by cos a plus sin a minus 1. We should prove that this is equal to cosecant a plus cot a. So I will start with left hand side. So left hand side, what I will do is I will divide the left hand side. I will divide both numerator and denominator by sin of a. So when I divide, I will get cos of a minus sin of a plus 1 by sin of a by cos of a plus sin of a minus 1 by sin of a. So if I divide both the numerator and the denominator, effectively there won't be any change. Okay, if I divide numerator by one value and denominator by another value, then that is wrong. Whenever we should divide both numerator and denominator by the same value. So here I am dividing by sin a. So effectively I am making no change. So now numerator I am going to split it. So cos a by sin a minus sin a by sin a plus 1 by sin a I will get. Okay, I am splitting all the terms. Denominator also I will split. Cos a by sin a I will get plus sin a by sin a minus 1 by sin a I will get. So now this is equal to cos a by sin a is cot a. Okay, cot a minus sin a by sin a will get cancelled. I will get 1 there plus 1 by sin a is cosecant a divided by, now in the denominator cos a by sin a is cot a plus here sin a will get cancelled. I will get 1 minus 1 by sin a. 1 by sin a is 1 by cosecant a. 1 by sin a is cosecant a. So minus cosecant a I will get. So now I am going to rearrange this one. Cot a plus cosecant a minus 1 I will write in the denominator. Cot a plus 1 minus cosecant a. So numerator I did not rearrange, only denominator I did not rearrange, only numerator I rearranged. Okay, now this is equal to cot a plus cosecant a Now here minus 1 I can write as, what is 1 plus 1 plus cot square a. 1 plus cot square a is equal to cosecant square a, or 1 is equal to cosecant square a minus cot square a. So here I'll write in that form. Okay, instead of 1 I'll write cosecant square a minus cot square a. I'll write the whole divided by denominator as it is. I'll write cot a plus 1 minus cosecant a. Now this is equal to, now see, this cot square a minus cosecant square a minus cot square a, this is in the form of a square minus b square. So a square minus b square is equal to a plus b into a minus b. Okay, so now cot a plus cosecant a. Now this cosecant square a minus cot square a I'll expand. So that is now cosecant a plus cot a into cosecant a minus cot a. Okay, now the whole divided by cot a plus 1 minus cosecant a. Now this is equal to, now in the numerator cot a plus cosecant a I can take common. Okay, cot a plus cosecant a I will take common, so I am left with 1 minus cosecant a minus cot a. Denominator I'll write as it is, cot a plus 1 minus cosecant a. Now here again in the numerator I'll open the brackets. So cot a plus cosecant a. So 1, when I open the bracket, the small bracket, not the square brackets, when I open the bracket I'll get 1 minus cosecant a. Now minus into minus plus cot a I will get, cot a, divided by denominator as it is, cot a plus 1 minus cosecant a. Now you can see I can cancel this and this, they are same, both are same. So I am left with cot a plus cosecant a, which is equal to right hand side. Exercise 11.4, question number 5, sub question 6. Prove that square root of 1 plus sin a by 1 minus sin a is equal to secant a plus tan a. So here in the left hand side square root symbol is there, and in the right hand side there is no square root symbol. So I should get rid of that square root symbol. Okay, to do that what I will do is, in the left hand side I will multiply and divide numerator and denominator by square root of 1 plus sin a. So when I do that, effectively there is no change. For example, see 1 by 2 is 0.5. So for 1 by 2, if I multiply and divide both numerator and denominator by 3 and 3, I'll get 3 ones are 3, 2 3s are 6. 3 divided by 6 also is 0.5 only. Okay, so I'll now left hand side I can write as 1 plus sin a by square root of 1 minus sin a. I can write like this. Now multiply and divide both side, numerator and denominator, by 1 plus sin a, square root of 1 plus sin a. So when I do that, what will I get? So here square root of 1 plus sin a, the whole square I'll get. Okay, then divided by, now here denominator I can write as square root of 1 minus sin a into 1 plus sin a. Okay, now here this square root symbol and this power of 2 will get cancelled. In the numerator I will be left with 1 plus sin a only. Now coming to the denominator, square root of, now denominator is in the form of a minus a plus b into a minus b is equal to a square minus b square. Okay, now 1 minus sin a into 1 plus sin a I can write as 1 square minus sin square a. Now this is equal to 1 plus sin a. So we know that the identity that sin square theta plus cos square theta is equal to 1. Okay, or cos square theta is equal to 1 minus sin square theta. So here denominator 1 square minus sin square is just 1 minus sin square theta, sin square a. So this will become 1 plus sin a by square root of 1 minus sin square is cos square a, cos square a. So 1 plus sin a divided by square root of cos square a is just cos a. Okay, square root of 2 square is equal to just 2, like that only. Here square root of cos square is cos a. Now this I can split now, 1 by cos a plus sin a by cos a. 1 by cos a is secant a, sin a by cos a is tan a, which is equal to right hand side. Exercise 11.4, question number 5, sub question 6. Prove that sin theta minus 2 sin cube theta by 2 cos cube theta minus cos theta is equal to tan theta. So I'll take left hand side first and I'll divide both numerator and denominator by sin theta cos theta. If I do so, what will I get is sin theta minus 2 sin cube theta divided by sin theta cos theta divided by 2 cos cube theta minus cos theta by sin theta cos theta. If I divide both numerator and denominator by the same term, the value will not change. For example, you can check what is the value of 1 by 2. 1 by 2 is 0.5. So now for 1 by 2, if I multiply both numerator and denominator by 3, sorry, division, right? So if I divide if I divide 1 by 2 and 2 by 2, I'll get 0.5 by 1, which is equal to 0.5. The value will not change. So here also effectively I am making no changes, the value will not change. So now in the numerator, sin theta I'll take common, so 1 minus 2 sin square theta I'll get divided by sin theta cos theta, the whole divided by 2. Here I'll take cos theta common, cos theta. So now I'm left with 2 cos square theta minus 1 divided by sin theta cos theta. Now here sin theta will get cancelled, here cos theta will get cancelled. So I'm left with 1 minus 2 sin square theta by cos theta, the whole divided by 2 cos square theta minus 1 by sin theta. Now this I can write as, first numerator I'll write as it is 1 minus 2 sin square theta by cos theta. The denominator term I'll shift to the numerator. When I shift to the numerator, it becomes reverse, that means sin theta will come in the numerator and 2 cos square theta will come to the denominator. Now in the denominator in the numerator you can see that 1 minus 2 sin square theta is there. So this can be written as 1 minus 2 sin square theta is 1 minus cos square theta. Okay, this is equal to 1 minus, if I remove the bracket, 2 into 1 is 2, minus 2, minus into minus plus, so 2 cos square theta I will get. So now 1 minus 2 is minus 1 plus cos square theta, or this is equal to cos square theta. Okay, so 1 minus 2 sin square theta is equal to 2 cos square theta, that is this part. Okay, now instead of 1 minus 2 sin square theta, I'll write 1 minus 2 sin square theta I'll get as here 2 is remaining, here also 2 is remaining, 2 cos square theta minus 1 I'll get. So 1 minus 2 cos square theta is also equal to 2 cos square theta minus 1. So this is equal to 2 cos square theta minus 1 by cos theta into sin theta by 2 cos square theta minus 1. Now 2 cos square theta, 2 cos square theta, 2 cos square theta minus 1 will get divided with 2 cos square theta minus 1. Now I'll be left with sin theta by cos theta, which is equal to tan theta, which is equal to right hand side. Exercise 11.4, question number 5, sub question 8. Prove that sin a plus cosecant a the whole square plus cos a plus secant a the whole square is equal to 7 plus tan square a plus cot square a. So left hand side I'll start. Now a plus b the whole square is equal to a square plus b square plus 2ab. So using this identity I'll expand this one. So sin a plus cos a the whole square is equal to sin square a plus cosecant square a plus 2 into sin a cosecant a plus, now cos a plus secant a the whole square is cos square a plus secant square a plus 2 into cos a secant a I will get. So this is equal to sin square a plus cosecant square a. Now here you can see 2 sin a cosecant a, here these two will get cancelled and I'll get 2 only, because why? Sin a cosecant a is equal to, sin a is 1 by cosecant a, so 1 by cosecant a into cosecant a, both will get cancelled like this, so only 2 will be remaining. So plus cosecant square a plus secant square a. Now here also 2 cosecant a, 2 cos a secant a will get cancelled and only 2 will be remaining, because cos a into secant a is equal to, cos a is 1 by secant a, 1 by secant a into secant a, so these two will get cancelled. So that's why 2 cos a into secant a is only 2. Now sin square plus cos square a, this I'll write side by side, sin square a plus cos square a plus, now cosecant square a is 1 plus cot square a. Okay, this one, this cosecant square a is 1 plus cot square a plus 2 plus secant square a is 1 plus tan square a. Okay, now sin square a plus cos square a is 1, we know that. plus 1 plus cot square A plus 2 plus 1 plus tan square A plus, so one more 2 is remaining here, plus 2. Now 1 plus 1 plus 2 plus 1 plus 2 is 2, 2, 4, 5, 6, 7. 7 plus cot square A plus tan square A I'll get. So this is nothing but equal to right hand side. Exercise 11.4, question number 5, sub question 9. Prove that cosecant A minus sin A into secant A minus cos A is equal to 1 by tan A plus cot A. So they have given some hint. Simplify left hand side and right hand side separately. So I'll first go with left hand side. So cosecant A minus sin A. So this cosecant A is 1 by sin A. Okay, two terms are there. Okay, cosecant A minus sin A into secant A minus cos A is there. So cosecant A is 1 by sin A minus sin A. Secant A is 1 by cos A minus cos A. So I'll take LCM. If I take LCM, so sin A means sin A by 1, cos A means cos A by 1. So LCM of sin A and 1 is sin A only. So sin A, so 1 minus sin square A I'll get this into here LCM of cos A. LCM of cos A and 1 is cos A. So here 1 minus cos square A I will get. So this is equal to, now 1 minus sin square A is cos square A by sin A into 1 minus cos square A is sin square A by cos A. So we know that sin square A plus cos square A is equal to 1. Therefore sin square A is equal to 1 minus cos square A. Okay. Similarly 1 minus cos square A is equal to sin square A. So now here this square will get cancelled with cos A. This here square will get cancelled with sin A. I am left with cos A sin A. Okay, or sin A cos A is left. Okay, this I'll mark as 1 and I'll take right hand side separately now. Right hand side is 1 by tan A plus cot A. So this I'll put tan A as sin A by cos A plus here cos A by sin A. Cot A is cos A by sin A. Now take the LCM. So 1 divided by, so LCM of cos A sin A is sin A cos A. So here in the numerator I'll get sin square A plus cos square A. So this is equal to, what is sin square A plus cos square A is? That is 1. So 1 divided by 1 by sin A cos A I'll get. So in the numerator 1 is there. 1 means it is 1 by 1. So 1 by 1 into denominator I'll take to the numerator. So sin A cos A will come in the numerator and 1 will come to the denominator. So 1 into sin A cos A is sin A cos A. 1 into 1 is 1. So this is equal to 2 I'll put. So 1 is same as 2. Therefore LHS is equal to, right, 1 is equal to 2. Exercise 11.4, question number 5, sub question 10. Prove that 1 plus tan square a by 1 plus cot square a is equal to 1 minus tan a by 1 minus cot a, the whole square, is equal to tan square a. So first I'll take 1 plus tan square a by 1 plus cot square a. Now this is equal to now 1. So tan is sin by cos. So 1 plus tan square a means now sin square a by cos square a divided by 1 plus. Now cot square a I can write as cos square a by sin square a. Now take the LCM. Now 1 means 1 by 1. So LCM of 1 and cos square is cos square. LCM of 1 and cos square a is cos square a. So I'll get cos square a plus sin square a the whole divided by. Now here also 1 means 1 by 1. LCM of 1 and sin square a is sin square a. So I'll get here in the numerator sin square a plus cos square a. So we know that sin square a plus cos square a is equal to 1. So I'll get 1 by cos square a by 1 by sin square a I'll get. So now 1 by cos square a I'll write as it is. Now I'll bring the denominator to the numerator. If I bring it, sin square a will come to the numerator, 1 will come to the denominator. So 1 into sin square a, 1 into sin square a is sin square a. Cos square a into 1 is cos square a. So this is equal to, again I can write sin by cos a the whole square. So this is equal to tan square a. I'll mark this as 1. Now I'll take this the middle term is 1 minus tan a by 1 minus cot a. So this is equal to, now I'll substitute tan a is equal to sin a by cos a, 1 minus sin a by cos a divided by 1 minus cot a, I'll substitute as cos a by sin a. So now 1 here 1 means 1 by 1. So LCM of 1 and cos a is cos a. So cos a minus sin a I'll get the numerator. So again coming to the denominator here. So here 1 means 1 by 1. So LCM of 1 and sin a is sin a. So now sin a minus cos a. Okay, this middle term is actually 1 minus tan a by 1 minus cot a the whole square. Okay, so this write as it is, the whole square. Now this is equal to, now cos a minus sin a by cos a. Now denominator bring to the numerator. When I bring it, it becomes sin a minus cos a by sin a becomes sin a by sin a minus cos a. Numerator will come to the denominator will come to the numerator. Okay, this the whole square. Now the first term I'll write as, okay, cos a minus sin a I can also write as minus of sin a minus cos a. Okay, by cos a into sin a by sin a minus cos a. Effectively I have made no changes. Okay, cos a minus sin a I can also write as minus of sin a minus cos a. If I open the bracket, I'll get the same thing. Okay, cos A minus sin A. I can also write as minus of sin A minus cos A. If I open the bracket, I'll get the original only. Okay, now sin A minus cos A, sin A minus cos A, I can cancel. Okay, now I'm left with minus 1. So after cancelling, 1 will be there. So minus 1 into sin A by cos A, the whole square. Now here, this I can write as minus 1 the whole square into sin A by cos A, the whole square I can write. So minus 1 the whole square is plus 1. So this plus 1 into sin A by cos A is tan A. So 1 into tan A square I'll get. This is equal to tan square A. Now you can check 1 and 2 both are equal. Summary of this chapter. So in this chapter we learnt what is trigonometric ratios. So trigonometric ratios are defined with respect to a right angle triangle. So consider this right angle triangle ABC in which angle B is equal to 90 degree. So with respect to angle A, this side BC is called opposite side, and with respect to angle A, side AB is called the adjacent side, and sine of angle A is defined by opposite by hypotenuse side, that is BC by AC. And similarly cosine of angle A, so with respect to angle A, cosine A is defined as adjacent side by hypotenuse side. Similarly tangent of angle A, with respect to angle A, tan A is defined as opposite side by adjacent side. So tangent of angle A is also equal to sin A by cos A. And cotangent of angle A, with respect to angle A, cotangent of angle A is defined as adjacent by opposite side, and cotangent is also equal to cos A by sin A, and secant A is defined as hypotenuse side by adjacent side. Secant A is also equal to 1 by cos A, and cosecant A is hypotenuse side by opposite side, and cosecant A is also equal to 1 by sin A. And in the third point you can see that if one of the trigonometric ratios of an acute angle is known, the remaining trigonometric ratios of the angle can be easily determined. For example, if we know sin A, we can determine cosecant of A. Cosecant of A is 1 by sin A, so we can determine what is the value of cosecant A. Similarly, if we know cos A, we can also determine secant A. So if we know tan A, we can determine cot of A. Suppose if we know cos A, we can determine sin A also, because sin square A plus cos square A is equal to 1. Therefore if cos A is known, we can determine the value of sin A also. Similarly here you can see, if tan of A is known, we can determine the secant of A also using the identity secant square A minus tan square A is equal to 1. Similarly if cot of A is known, we can determine cosecant square A also. Next point is the values of trigonometric ratios for angles 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. So in this chart I already explained how to find all this value. Even if you don't remember the values, easily in 2 minutes you can make this chart and get all the values. Fifth point, the values of sin A or cos A never exceeds 1, whereas the values of secant A or cosecant A is always greater than or equal to 1. So in the chart you can see what is the value of sin 0. Sin 0 is 0 only. Sin 30 degree is 1 by 2, and sin 45 degree is 1 by root 2. So actually the values are increasing from 0 to 1 by 2 and 1 by root 2. This is greater than this value, and sin 60 degree is root 3 by 2. This value is greater than this value. Okay, every value is greater than the previous value, and sin 90 is 1. This is greater than sin 60. So the value sin A is increasing. Okay, at 0 it was 0, and for 90 it is 1. So the value of sin A or cos A never exceeds 1. So one more thing, and even in cos A you can see cos A is 1. Cos A is 1, cos 30 is root 3 by 2. So root 3 by 2 is lesser than 1, and cos 45 is 1 by root 2. 1 by root 2 is lesser than the previous value here, and cos of 60 degree is 1 by 2. So this is lesser than the previous value, and cos 90 is 0. So cos A value is starting from 1 and it is decreasing to 0. Sin A, it is starting with 0 and increasing to 1. So whatever it is, the values are ranging between 0 and 1 only. And also the point says whereas the values of secant A and cosecant A is always greater than or equal to 1. So in the chart you can see secant A is 1, sorry, secant 0 is 1, and secant 30 degree is 2 by root 3. 2 by root 3 is actually greater than 1, so it is increasing. Now again secant 45 is root 2. Root 2 is greater than previous value here, greater than 1 and greater than 2 by root 3. Now root 60 is 2. Now root 2 is greater than all these values, and secant of 90 is not defined. Actually this is a very high value. So actually secant A is starting with value 1 and it is gradually increasing. Okay, and coming to cosecant A, here also you can see that cosecant 90 degrees 1, and cosecant 60 degrees 2 by root 3. 2 by root 3 is lesser than, sorry, 2 by root 3 is greater than 1, and cosecant 45 degrees root 2. Root 2 is greater than 2 by root 3, greater than these two values here, and cosecant 30 degree is 2. So 2 is greater than all these values here, and cosecant 0, actually this is not defined. This is a very high value. So secant A, values of secant A and cosecant A is always greater than 1 or equal to 1 only. And these are complementary ratios of complementary angles. So what are complementary angles? Complementary angles are angles whose sum is equal to 90 degree. Now in this right angle triangle you can see the sum of angle A plus angle C is equal to 90 degree. So that's why we call angle A and angle C as complementary angles. Now sin A is equal to opposite by adjacent, that is BC by AC. BC by AC is also equal to cos of angle C. Sin of angle A is also equal to cos of angle C. So cos of angle C, now if I substitute angle C is equal to 90 minus A, I will get like this, cos of 90 minus angle A. Similarly, cos of angle A is also equal to sin of angle C, which is equal to sin of 90 minus angle A. And similarly, tan of angle A is equal to cot of 90 minus angle A I will get. Similarly, cot of angle A is I will get as tan of 90 minus angle A. Similarly, secant of angle A I will get cosecant of 90 minus angle A, and cosecant of angle A I will get as secant of 90 minus angle A. The main observation that you should make in case of complementary angles are sin will change to cos, cos will change to sin, tan will change to cot, cot will change to tan, secant will change to cosecant, and cosecant will change to secant. And the last is trigonometric identities. The three identities are sin square a plus cos square a is equal to 1, and next is secant square a is equal to 1 plus tan square a. So this can also be written as secant square a minus tan square a is equal to 1, and the last one is 1 plus cot square a is equal to cosecant square a. These are the three identities, and that completes this chapter.